Hello there and welcome back to the Sleep Science, or maybe tonight it's more like space science, because you're about to leave your cozy blanket orbit and drift into the Milky Way itself. The lights in your room fade until you're left with nothing but the faint glow of your screen, tiny, fragile, and flickering against a backdrop that stretches for 100,000 light years. You can almost feel the tilt of your chair become the tilt of Earth, spinning at over 1,000 miles per hour, yet somehow perfectly still in the galactic quiet. You probably won't survive this, not because of any danger, but because your mind might implode under the sheer size of what's coming. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're listening from somewhere special, drop your location and local time in the comments. It's oddly comforting to know where in the world all these sleepy minds are tuning in from. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The first thing you notice when you leave Earth behind, metaphorically of course, is how unbelievably busy our little corner of the universe already is. The moon hangs just 384,000 kilometers away, smugly tugging on the tides as if it owns the place. Mars looks like a rusted coin flipping slowly in the void. Beyond that, Jupiter glows like a faint nightlight, its storms brewing for centuries longer than human civilization has existed. And yet, even if you gathered every planet, moon, asteroid, and cosmic speck in our solar system, they'd all still vanish into a single pixel when compared to the Milky Way. It's like realizing your entire family photo album fits on one grain of sand at the beach. You glide past the asteroid belt and notice how deceptively empty it feels. Hollywood lied to you about that one. Space isn't a chaotic minefield of tumbling rocks, it's mostly emptiness, with just enough matter floating around to remind you it's real. Historians still argue whether the ancients who charted the wandering planets could have ever imagined what they truly were. Massive worlds circling an ordinary star halfway down one spiral arm of a middling galaxy. Probably not. They were too busy making up excellent myths about sky gods and divine messengers. Honestly, who could blame them? Facts weren't nearly as cinematic. Your imaginary ship picks up speed, zipping past the orbit of Pluto, the on-again, off-again planet whose identity crisis still sparks gentle internet wars. Somewhere out there, Voyager 1 drifts farther and farther, still sending faint signals home after almost half a century. The mainstream fact, Voyager 1 officially entered interstellar space in 2012, becoming humanity's most distant emissary. The quirky tidbit, its golden record carrying greetings and sounds from Earth, includes the brainwaves of a woman in love. Yes, actual feelings, encoded and flung toward eternity. If aliens ever find it, they'll learn that our species measures the universe in both math and emotion. You're now far enough away to see the sun not as a blinding disk, but as just another spark among billions. It takes light about 8 minutes to reach Earth, but over 4 years to reach the next nearest star, Proxima Centauri. If your phone took that long to load a page, you would hurl it into the void, but in galactic terms, that's next door. The scale is ridiculous. The numbers start losing meaning. Astronomers say the Milky Way spans roughly 100,000 light years across. That's 100,000 years of light speed travel, no snack breaks, no bathroom stops, no hope of turning around. And still, compared to the observable universe, our galaxy is just a shimmering snowflake in a cosmic blizzard. Somewhere along this mental journey, your sense of self starts to compress. You can't help but laugh, softly, almost nervously, because realizing how small you are has a strange kind of comfort to it. The galaxy doesn't care if you forget to reply to emails, or if your toast burns. You could scream your entire biography into the void and space would simply yawn, still expanding. Yet that's also the miracle. Out of this vast nothingness, a thin film of matter on a tiny planet figured out how to look up and understand where it sits. A thought crosses your mind. If the Milky Way were scaled down to the size of North America, our whole solar system would fit inside a coffee cup somewhere in Kansas. You can almost picture it, a little cup swirling quietly while hundreds of billions of other stars blaze across the continent. Somewhere near the coasts, supergiant stars burn through their lives in a few million years, while in the cold interior, ancient red dwarfs blink patiently, older than human memory itself. Astronomers still argue whether the Milky Way's star count is closer to 100 billion or 400 billion, because counting stars is, unsurprisingly, really hard when you live inside the thing you're trying to measure. The classical historian in you, yes, there's one hiding in there, remembers how ancient cultures saw this hazy streak across the sky. The Greeks called it Galaxius Kyklos, the Milky Circle, born from the goddess Hera's spilled milk. The Mayans imagined it as the cosmic river, while in China it was the Silver River, separating two star-crossed lovers. You can't help but smile. Even back then, people sensed they were part of something vast, and these stories made that vastness feel personal. You glide a little farther now, your imaginary camera lens widening until the solar system is gone. The spiral arms of the Milky Way stretch around you, faint and diffuse, and for the first time you see what we truly are, a microscopic shimmer tucked inside a grand rotating disk of stars. If this were a city, we'd live somewhere in the quiet suburbs, far from the noisy downtown core. A safe spot, really. The core of the galaxy is a volatile place full of radiation storms, star collisions, add-up and black hole tantrums. Not exactly the best real estate for life. Out here, things move slower, quieter. Maybe that's why Earth got the time and space to grow oceans, forests, and the occasional sarcastic narrator. For a moment, you stop trying to comprehend and just feel. The galaxy hums, not audibly, but in the silent pulse of light, radiation, and gravity that binds it together. You, a temporary flicker of consciousness, are witnessing something that stretches beyond comprehension, and somehow that's enough. The joke, of course, is that you can't ever really leave home. Every atom in your body was once forged in stars scattered throughout this very galaxy. You've been here all along, just rearranged. And as the Milky Way slowly turns, like a slow-breathing animal asleep in darkness, you realize this isn't a story about how small you are. It's a story about how lucky you are to notice it. You blink, and the vast swirl of starlight freezes before you like a photograph that's almost too large to process. How do you even measure something like this? The Milky Way doesn't come with a handy ruler taped to one spiral arm, and it's not like you can step back far enough to get a proper view. You're inside it, like trying to figure out the shape of your own house while standing in the broom closet. And yet somehow, scientists have pulled it off. The trick lies in patience, light, and geometry so old it would make Pythagoras blush. The journey starts with parallax. Imagine holding your thumb up at arm's length, closing one eye and then the other. Your thumb seems to jump against the background, tiny but measurable. Astronomers do the same thing, except their eyes are opposite sides of Earth's orbit around the Sun, 300 million kilometers apart. By comparing how a star's position shifts across 6 months, they can calculate how far away it is. That's the easy part, up to a few thousand light years. After that, the angles get so microscopic you'd need a ruler the size of Jupiter. This is where radio waves step in, rippling through the galactic dust like sonar in an ocean. In the 50s, astronomers realized they could map the Milky Way by tracking hydrogen's signature 21-centimeter radio line. That steady hum of interstellar hydrogen reveals spiral arms where stars are born and die. It's the galaxy's heartbeat, and you're listening to it through instruments the size of mountains. The mainstream historical fact. The first complete radio map of the Milky Way was assembled in 1952, marking humanity's first real peek at the structure we live inside. The quirky tidbit? The project was partly inspired by World War II radar technology, proof that even wartime paranoia can occasionally lead to cosmic enlightenment. You imagine yourself floating among those invisible waves, the radio static becoming a cosmic lullaby. Each pulse, each echo adds one more breadcrumb on the path toward understanding. But no map ever feels complete. Historians still argue whether the Milky Way truly has 2 main spiral arms or 4, because dust clouds obscure our view from every direction. It's like trying to sketch your hometown during a permanent sandstorm. Even the European Space Agency's Gaia mission, which has charted over 1 billion stars with robotic precision, occasionally finds itself humbled by the sheer messiness of reality. From your vantage point, though, the Milky Way looks like pure order. A luminous pinwheel drifting in slow motion, light years thick, arms curling like ribbons of smoke. You'd expect a grand symmetry, but there's a subtle wobble, a warp, as if the galaxy had a sore back. It turns out that gravity from nearby galaxies tugs unevenly on our disk, twisting it like a vinyl record left in the sun. Our cosmic home, it seems, is not perfectly poised, but slightly bent, wobbling through time, somewhere, A perfectionist astronomer is probably losing sleep over that. You glide toward a brighter patch of stars and realize how easily numbers fail to capture the experience. Scientists toss around light years as if it's just another measurement, but it's a year of light travel. That's nearly 10 trillion kilometers per unit. Say you wanted to measure the distance to the galactic center, about 27,000 light-years away. Even if you hopped on the fastest spacecraft ever built, it would take you more than 4 million years to arrive. You'd miss every possible season of your favorite show, plus the extinction of humanity, plus several rounds of evolution. The Milky Way doesn't rush for anyone. You pause by a glittering cluster, the Pleiades, also known as the Seven Sisters. They shimmer like a tiny jewel box, though in reality they're 400 light-years away and span over 40 light-years across. Cultures all over Earth named them long before telescopes existed. The Greeks saw them as sisters pursued by Orion. The Japanese call them Subaru, which explains that car logo you've probably been stuck behind in traffic. You chuckle softly at that cosmic marketing coincidence. The ancient and the modern share the same sky, only the interpretations have shifted. Measuring stars also means measuring time. The light from the Pleiades began its journeys around the same era when Leonardo da Vinci was sketching flying machines. Every twinkle you see is a message from the past, crossing space to land in your half-sleepy eyes. The universe has no present tense, only echoes arriving at different moments. That realization hits you like a soft breeze when you gaze up at the Milky Way. You're time traveling without even trying. Farther out, you notice a strange rhythmic blinking. Pulsars, the lighthouses of the galaxy. These are collapsed stars spinning hundreds of times per second, sending out beams of radio waves like cosmic metronomes. Astronomers use them as navigational anchors like GPS satellites for the universe. The mainstream fact: in 1967, Jocelyn Bell Burnell discovered the first pulsar, initially labeling it LGM-1 for little green men, because the signal was so unnaturally precise, the fringe tidbit. Some UFO enthusiasts still insist that pulsars are interstellar communication beacons. Historians still argue whether early SETI programs secretly hoped those rhythmic blips were signs of intelligent life rather than stellar corpses. You float between these invisible markers, feeling the scale expand again. The Milky Way stops being a map and becomes more like a living organism. Arteries of gas, capillaries of dust, heartbeats of radiation. You're no longer just learning about it, you're inside its pulse, riding the glow between birth and death of countless suns. Each measurement, each observation is a love letter from humans to the cosmos. We see you. We're trying to understand, O Baum. There's an absurd kind of beauty in that struggle. Scientists can model the entire galaxy in supercomputers, simulate the gravitational dance of stars for billions of years, and still be unsure about basic details, like how thick the galactic disk actually is. Depending on the model, it's anywhere from 1,000 to 3,000 light years. That's the astronomical version of estimating your own height to within a factor of 3. Yet somehow, despite the fog of uncertainty, humanity keeps refining the picture, one photon at a time. You think of sailors in the age of exploration, charting coastlines by dead reckoning and starlight, long before satellites or Google Earth. Their maps were messy, patchy, full of guesses, and yet they were enough to keep going. Maybe cosmic cartography isn't so different. We measure the unmeasurable, not because we expect perfection, but because wonder itself demands to be pursued. As you drift through that shimmering map, you realize that every line, every contour of the Milky Way we've drawn is just a story told in data. The story keeps changing as we learn more, but the awe stays the same. You might be small, yes, but you're also part of the only known species that decided to measure infinity and make it personal. That's got to count for something. You keep floating, and the view keeps unfolding as though the universe itself were sputterly peeling away its layers just for you. The map you imagined in the last section stretches wider now, revealing where exactly you fit inside this galactic sprawl. A cosmic address that sounds almost poetic when you say it aloud. You live on planet Earth, orbiting an average G-type star called the Sun, about 26,000 light-years from the galactic center, nestled within a minor spur of the Orion Arm. That's it. That's your full return address in the Milky Way. Please include a postage worth a few billion years if you ever plan to send a letter home. You zoom out from the solar system again, retracing your path past Neptune's faint glimmer, and suddenly the sun shrinks into anonymity among hundreds of billions of neighbours. Most of them are far dimmer than ours. The Milky Way's average star is a cool red dwarf, so faint that if one sat in our sky where the sun is, you'd need a telescope just to notice daytime. It's humbling to realise that the sun, the fiery centrepiece of your entire world, is actually something of a B-list celebrity on the galactic scale. And yet, it's special to you. You can almost hear the narrator of your own thoughts smirking. Congratulations, you orbit a perfectly ordinary star. As your viewpoint pulls back, you start to see where this ordinary star lives, inside the Orion Arm, a slender bridge of gas and stars sandwiched between two grander spiral arms, Sagittarius and Perseus. Scientists used to call our region the Orion Spur, which sounds faintly disappointing, like the galactic equivalent of a highway rest stop, but recent surveys hint it might be more important than we thought. Perhaps a genuine mini-arm rather than a side street. Historians still argue whether that upgrade in status counts as astronomical vanity. But hey, it feels nice to live in an up-and-coming neighbourhood. Farther along the arm, you notice bright clusters like the Carina Nebula and the Eagle Nebula, star nurseries glowing pink and violet in ultraviolet light. The mainstream fact: these regions are where hydrogen collapses under gravity to form new suns and planets, recycling the ashes of old ones. The quirky tidbit: in the early 20th century, some astronomers speculated that nebulae were actually holes in the heavens, empty gaps through which we glimpse divine light. They weren't even close, but you've got to admire the creativity. You pause here and picture the sun orbiting the galactic core, tugging its family of planets along like a parent walking an impatient group of toddlers. Every second, our whole solar system barrels through space at about 828,000 kilometers per hour. You don't feel it, but it's happening right now, an endless commute along the glowing spiral highway. It takes the sun roughly 230 million years to complete a single orbit around the Milky Way. That means, since its birth, it has circled the galaxy only about 20 times. Dinosaurs, by the way, appeared about halfway through the sun's current lap, so yes, we're still mid-orbit in the same cosmic year that saw T-Rex stomp across the planet. If you squint toward the centre of the galaxy, a hazy bulge of stars crowds together, like the glowing heart of some ancient creature. Dust clouds curl across it, blocking the view in visible light but glowing richly in infrared. You imagine what it would feel like to stand somewhere inside that bulge, a night sky so bright with stars that darkness simply doesn't exist. Historians still argue whether ancient astronomers ever glimpsed faint hints of that central concentration, noting how some early star catalogues placed mysterious bright patches near Sagittarius. They had no idea they were staring toward the gravitational navel of the Milky Way. It's here, in Sagittarius, that the coordinates of home truly become dizzying. The sun isn't near the edge, nor the centre, but somewhere in the comfortable middle, an interstellar suburbia with just enough quiet to nurture complex chemistry and the odd bout of existential dread. The neighbourhood density is cosy, roughly one star every few light years. In the galactic downtown, that spacing shrinks to fractions of a light year, stars rubbing shoulders like commuters on a cosmic subway. You're grateful for the breathing room out here. Crowded regions are dramatic to look at, but lethal to live in. Radiation storms, supernova blasts, and gravitational chaos make poor conditions for a Sunday nap. From this perspective, Earth's whole history feels like a whisper within a whisper. You think of the earliest humans who looked up and tried to explain that milky band across the night. To the ancient Greeks, it was Hera's spilled milk. To the Vikings, a road to Valhalla. To the Quechua of the Andes, a celestial river whose dark clouds shaped the constellations of llamas and serpents. So many cultures found their reflection in that shimmering stripe. You can't help but chuckle at the idea that across time and language, everyone's been trying to assign meaning to the same swath of distant suns. The galaxy doesn't change, only our stories about it do. The sun's position may feel random, but it's perfect for visibility. If we were buried deeper in the core, we'd be blinded by constant starlight. If we were further out toward the rim, there'd be too little light for ancient eyes to even notice the Milky Way band. Here in the middle, we get just enough of everything: perspective, safety, and a night sky worth dreaming about. The universe doesn't hand out participation trophies, but if it did, our solar system might win Best Balanced Location for philosophical reflection. As you drift farther, the spiral arm below you looks like a living river of gold dust. The sun traces its looping path in the galactic plane, and you start to understand that home is more dynamic than you ever imagined. Every star you see tonight is on its own orbit, moving through an invisible gravitational choreography that's been going on for 13 billion years. Nothing is fixed. Not your planet, not your star, not even the galaxy's shape. The thought could be terrifying, but it isn't. It's oddly reassuring, like realizing the universe is in constant motion and you're simply part of its flow. You turn your gaze back toward that faint bluish speck we call home. Earth spins and hums along the sun's orbit, blissfully unaware of its dizzying dance. And as you watch it shrink to invisibility, a soft truth settles in. We're small, yes, but we're perfectly placed to look out and wonder. You linger in that spiral arm for a moment longer, letting the soft glow of a billion suns wash over you. And then something curious happens. The galaxy begins to move beneath you. Not that it wasn't moving before, of course. The Milky Way is in constant motion, but now you can see it. The sun drifts along its path like a steady golden ember, towing its retinue of planets, comets, and wayward asteroids around this galactic core in a nearly perfect orbit. You realize that, in cosmic terms, you're riding a moving walkway that makes the solar system feel both wildly dynamic and profoundly predictable. Every creature that's ever lived has done so while surfing this enormous wave of motion, completely unaware that they were, in a very real sense, passengers on a slow carousel nearly 230 million years long. The numbers, as always, border on the ridiculous. The sun travels around the galactic center at roughly 828,000 kilometers per hour, about 514,000 miles per hour if you're a fan of imperial absurdities. At that speed, you could circle Earth in under 3 minutes. Yet because the galaxy is so incomprehensibly vast, you haven't even made a full orbit since the dinosaurs went extinct. You, me, every ancestor, every recorded word in human history, all of it has happened within the same segment of one galactic year. You probably haven't even reached the quarter mark yet. Talk about running late for the ultimate lap. Historians still argue whether early astronomers fully grasped this orbital motion. Copernicus and Galileo figured out Earth's dance around the sun, but it wasn't until the 18th century that William Herschel, armed with homemade telescopes and sheer stubbornness, started to suspect that the sun itself was moving through space. He called the direction the solar apex, pointing roughly toward the constellation Hercules. The mainstream fact and sinned, his star catalogue was one of the first attempts to map stellar motion, a foundation for modern galactic dynamics. The quirky tidbit. Herschel's sister Caroline, who helped with the calculations, became the first woman to earn a salary for scientific work in England, proof that even the galaxy's motions couldn't outpace her precision. You picture the sun's orbit as a glowing ribbon wrapping the galactic centre, but it's not a smooth track. It wobbles, up and down through the galactic plane, like a cosmic dolphin surfacing and diving through a stellar sea. Every 30 million years or so, our solar system passes through the densest part of the Milky Way's disk. Some researchers speculate that these periodic crossings could influence life on Earth, perhaps triggering comet showers or subtle climate changes. It's still debated, of course. Historians and astrophysicists alike argue whether those celestial ripples line up with extinction events, or if that's just our human urge to find patterns in chaos. Either way, it's a haunting thought that our planet's history might rise and fall with the sun's rhythmic motion through invisible tides of stars and dust. From your perspective out here, that up and down drift looks graceful, almost hypnotic. The Milky Way's thin disk gleams like a halo of smoke, and the sun skims its surface like a skipping stone. Gravity is both jailer and choreographer here. It dictates every curve, every oscillation, but the result is pure elegance. You can almost hear the faint hum of orbits overlapping, stars circling faster near the centre, slower at the edges, all balanced by forces too subtle to sense. It's like watching a clock whose gears are made of suns. You drift closer to the galactic core and notice the rotation speed rising sharply. The inner stars whip around faster, defying what Newtonian physics alone can explain. By all rights, the galaxy should tear itself apart, but it doesn't. Something unseen holds it together. Dark matter, that mysterious cosmic glue that refuses to show itself directly. But we'll get to that enigma later. For now, you're just observing the sun's patient orbit, looping endlessly through this glittering whirlpool without ever realizing how small a role it plays. If the galaxy were a giant record spinning on a turntable, the sun would be a fleck of dust riding near the outer groove. The track beneath it, the background of stars, doesn't stay still either. Spiral arms aren't solid, they're patterns of density that stars move through like cars passing a traffic jam. The sun drifts in and out of these denser lanes every 100 million years or so. Astronomers call it spiral arm crossing, and it's one of the quieter forms of cosmic migration. During one such crossing, around 60 million years ago, a nearby supernova may have sprinkled Earth's oceans with iron-steel isotopes, tiny evidence of stellar death reaching our shores. You imagine the faint dust settling over the seas unnoticed, while early mammals scurried through ferns under unfamiliar skies. Every orbit, every crossing, every wobble, these are the rhythms of cosmic time. The scale is so immense that it makes human calendars look like the blinking of a cursor on a dark screen. You think of how civilizations built temples aligned with the rising sun, tracking seasons and solstices, but no one carved a monument to mark the sun's galactic year. Maybe they should have. It would take about 250 million years for the next new orbit celebration, give or take a few million. Better start planning the decorations now. You laugh softly, though the sound doesn't travel in space. The humour keeps the perspective bearable. You can't truly imagine 230 million years. The brain just isn't wired for it. But you can feel the scale emotionally, the way the sun's orbit turns all of human history into a mere heartbeat. Somewhere, deep inside that star, hydrogen atoms fuse into helium, releasing the light that will take 8 minutes to reach Earth and maybe 10 billion years to fade for good. The sun doesn't care about its path, it simply burns, hums, and moves. It's the galaxy's slow heartbeat, and you're part of its pulse. For a fleeting moment, you wonder what the view will be when the sun finally finishes its lap, if there will still be humans, or oceans, or even continents. Maybe by then, our descendants, or their artificial successors, will be mapping other galaxies, gliding through the stars that were once just dots in the night sky. The orbit will continue, with or without witnesses. You turn back toward your tiny, fragile planet, glowing faintly in that galactic twilight. Somewhere down there, someone's probably stressing about traffic, taxes, or burnt toast. They don't know they're racing around the galaxy at 500,000 miles per hour, completing a cosmic circuit that won't finish for another 200 million years. And somehow that feels perfect. Life doesn't need to keep up with the galaxy, it just needs to notice it every now and then. You tilt your gaze inward now, toward the galactic center, where everything spins faster, denser, and far stranger. If the Milky Way were a living creature, this would be its heart, pulsing with ancient power and gravitational fury. And right in that heart lies one of the most intimidating characters in all of cosmic history, Sagittarius A. The supermassive black hole. Just saying the name feels like invoking something mythic. It sits roughly 26,000 light-years from you, invisible to human eyes but more influential than any emperor who's ever ruled a patch of dirt on Earth. Imagine the very fabric of space there, folded, crushed, and humming with energy. Sagittarius A weighs about 4 million times as much as the Sun, yet it fits inside a region smaller than Mercury's orbit. You picture that impossible mass squeezing inward. Its gravity so extreme that even light, the universe's speed champion, can't escape. You know what that means. Once something crosses the event horizon, it's gone forever. No takebacks, no final postcards, not even a flash of farewell. The galaxy orbits politely around this monster, like dancers circling a bonfire they can't quite look at. The mainstream historical fact: humanity first detected Sagittarius A in 1974 thanks to radio astronomers Bruce Ballack and Robert Brown, who noticed an intense, compact source of radio waves in the constellation Sagittarius. The quirky tidbit. For a while afterward, scientists weren't entirely sure if it was one object or many. They nicknamed it the compact radio source, which sounds hilariously underwhelming for something capable of devouring stars. Historians still argue whether early skepticism slowed our acceptance of black holes as real physical entities or saved us from premature cosmic melodrama. Either way, the name stuck, and so did our fascination. You glide closer, just far enough to see how the centre blazes, not with light from the black hole itself, but from the chaos swirling around it. Gas clouds spiral inward, heating up to millions of degrees, shining in X-rays before vanishing. Stars slingshot through this maelstrom at breakneck speeds, some completing entire orbits in a matter of years. One of them, known as S2, swoops so near the black hole that it moves at 3% of light speed. You can almost imagine the roar of gravity there, though of course there's no sound, just the silent curvature of space-time bending under invisible weight. There's beauty amid that violence. The light from the surrounding stars flickers like candle flames caught in a storm, their trajectories curved by the immense gravity. You watch them trace ellipses so precise they could double as cosmic calligraphy. The black hole's presence isn't just destructive, it's architectural. It keeps the Milky Way's core intact, its gravity anchoring the galactic disk and maintaining the rhythm of rotation. Without that hidden engine, the entire structure might slowly unravel into interstellar soup. There's a strange comfort in that, a reminder that even the most terrifying things in nature often double as the glue that holds everything together. But the centre isn't peaceful. Radiation flares burst unpredictably, and magnetic fields twist like angry vines. You see thin jets of material sometimes shooting out thousands of light years, glowing faintly before fading into the halo. Astronomers still debate whether Sagittarius A was more active in the past. Some evidence hints that millions of years ago, it unleashed a pair of colossal gamma-ray bubbles, extending above and below the galactic plane. Picture two ghostly balloons made of radiation, each tens of thousands of light-years tall. If true, that would mean our calm, modest black hole once had a temper. Fortunately, it's been napping for most of human history. You imagine standing on a hypothetical planet orbiting near the galactic centre. The night sky there would be a riot of brightness. Thousands of stars so close that shadows might vanish completely. But it would also be a short-lived paradise. The gravitational interactions would shred solar systems before life could settle. The universe, as usual, trades beauty for danger. Out here in the galactic suburbs, our night sky may look sparse, but that emptiness is a blessing. It's the difference between a bustling city centre that never sleeps and a quiet countryside where thoughts have room to breathe. You drift above the plane now, looking down at the heart of the Milky Way as though viewing a glowing whirlpool from above. Dust lanes crisscross it like veins. The whole structure rotates with stately patience. Somewhere the sun and its tiny retinue complete their invisible circuit, utterly unaware of the dark monarch at the centre. That realization gives you a shiver, a pleasant one, the kind you get when you realize the world is bigger, older, and more intricate than you ever imagined. Every so often you catch faint ripples spreading through space-time, gravitational waves, tiny tremors produced when black holes merge or stars fall too close to their doom. Instruments like LIGO and Virgo on Earth can now detect such ripples, translating cosmic cataclysms into audible chirps. You think of that, humans building machines delicate enough to eavesdrop on the universe's heartbeat. Somewhere between the roar of collapsing stars and the hum of your bedside fan, the two sounds almost rhyme. And then there's the philosophical part, sneaking in as always. The Milky Way's centre, this region of light and shadow, mirrors something deeply human. We're drawn to mysteries we can't directly see, compelled by invisible forces that shape everything around us. You've never felt gravity itself, and you've only felt its consequences. Likewise, you'll never witness Sagittarius A directly. You'll only see the stars that dance around its influence. Maybe that's how curiosity works. It's not the thing we can see that changes us, but the pull of what lies beyond sight. You linger for another moment, letting that thought settle like cosmic dust. The stars whirl, the black hole breathes in silence, and you, one more tiny observer among billions, float just far enough away to admire the balance of destruction and order that makes the galaxy whole. You drift away from the galactic centre now, following one of the curving arms outward where the chaos begins to ease. Here, stars scatter into quieter neighbourhoods, the thick clouds of gas thinning into faint ribbons. It's a gentler space, a place where you can finally breathe, or you would, if there were air. The darkness isn't empty, it's full of suns too far apart to light each other's skies. The galaxy's arm stretches beneath you like a frozen wave, every pinpoint of brightness a star burning through its own impossible story. You let your gaze wander, and soon the Milky Way stops being an abstract structure and becomes something intimate, almost familiar. From your current vantage point, the stars look close enough to touch. Some glow with soft amber hues, others, younger and hotter, flare in sharp white or blue. The scale is deceptive. Each one is separated from its nearest neighbour by several trillion kilometres. If you tried to visit even the closest of them, you'd spend tens of thousands of years just crossing the space between. Yet the view doesn't feel lonely, it feels symphonic. Each star contributes to a grander pattern, and from Earth, that pattern blurs into the glowing streak we call the Milky Way. One particular region catches your eye, the Omega Centauri cluster, a swarm of 10 million stars packed so tightly that the night sky there would blaze almost continuously. The mainstream historical fact, Omega Centauri was once thought to be just another globular cluster, until astronomers realised it might actually be the remnant core of a dwarf galaxy long ago consumed by the Milky Way. The quirky tidbit: if you could somehow stand on a planet inside that cluster, assuming your atmosphere didn't vaporise from radiation, you'd be able to read by starlight alone. Historians still argue whether the Milky Way's gravity truly shredded that ancient galaxy, or if Omega Centauri is simply an unusually ambitious cluster that went overboard. Either way, it's a glittering monument to cosmic cannibalism. As you pass through these dense regions, you notice how every star seems to hum with a slightly different rhythm. Some are newborns, still wrapped in dusty cocoons. Others are ancient red giants, their outer layers puffing away in shimmering clouds. The youngest glow fiercely blue, burning through their fuel in a few million years. The elders, cooler and dimmer, could last for trillions, far longer than the universe has currently existed. You realise that time here doesn't flow like it does on Earth. There's no such thing as an average lifespan when your candles are made of plasma and your clocks run on fusion. Your path carries you toward a loose cluster called the Hyades, not far, in cosmic terms, from where our Sun resides. It's one of the nearest open clusters, and astronomers often use it to calibrate their distance scales. You can almost imagine early stargazers tracing its faint pattern in Taurus, unaware that those dots were siblings, stars born from the same cloud, drifting apart slowly, like family members moving to different cities. You can't resist a soft smile. Even in space, the metaphor of kinship holds. As you drift, a particular star catches your attention. Betelgeuse, the swollen red shoulder of Orion. It pulses faintly, a giant nearing the end of its life, its outer layers trembling as they prepare for collapse. The mainstream fact: Betelgeuse is roughly 700 light-years away and about 1,000 times larger than the Sun. The fringe tidbit: in early 2020, the star dimmed so dramatically that millions of people online thought it might go supernova in our lifetime. It didn't, of course. Astronomers later discovered that a puff of ejected dust had simply drifted between Betelgeuse and Earth like cosmic stage smoke. Still, historians will likely argue for decades about how that single dimming event managed to unite astrophysicists, conspiracy theorists, and meme creators for a few glorious weeks. You linger near a cluster of binary stars, two suns locked in orbit around each other, their gravitational tug a slow and elegant waltz. The light they cast merges into a soft golden glow, but if you were close enough, you'd see one star swell while the other siphons gas from its surface. It's not an act of cruelty, it's just physics being dramatic again. Some binaries even trade mass so often that they blur the line between individuality and merger. Watching them, you start to suspect that the universe loves stories of companionship and entropy equally. Between these luminous islands, vast spaces of darkness stretch out. They look empty, but they aren't. Invisible hydrogen atoms drift there, waiting patiently to condense into the next generation of stars. Cosmic rays zip through unseen, relics from ancient explosions. Dust grains, tiny stubborn survivors, float like cosmic pollen. This darkness is the womb of everything luminous, and you can't help but think that if silence had a physical form, this would be it. Your mind wanders to how humans have catalogued all this, turning anonymous dots into named entities: Sirius, Vega, Deneb, Rigel. Every name is a bookmark in our relationship with the sky. The Greeks, Arabs, Chinese and Polynesians all mapped the stars differently, but they shared the same impulse: to connect the glittering chaos into pictures that meant something. We still do it, though now with satellites and data instead of myth. There's poetry in both approaches, you think. One uses stories to tame infinity, the other uses numbers. Either way, it's still us, staring upward, refusing to accept that the darkness is meaningless. And as you pass through another arm of the galaxy, you catch yourself whispering, not words exactly, but an acknowledgement. Every star out here is both ancient and ongoing. Some of the light reaching your eyes tonight began its journey before humans evolved language. To witness it now is to intercept a message that's been travelling for thousands of millennia, finally finding an audience on a tiny blue world orbiting a small forgettable star. You can almost feel the weight of that distance, but instead of crushing you, it lifts you. Because right now, as you float through this sea of stars, you're not just observing the Milky Way, you're inside its memory. You drift deeper into the galaxy's midsection, where light thickens and colour begins to bloom. The starlight around you softens into clouds, misty, radiant folds of dust and gas that stretch for hundreds of light years. These are nebulae, the galaxy's true lungs, inhaling and exhaling starlight, recycling cosmic matter into new beginnings. You can almost smell them if smelling were possible in a vacuum, a blend of ozone, iron, and something faintly sweet, like the scent of rain on metal. Each nebula tells a story of death and rebirth, of ancient suns that exploded and scattered their ashes, leaving raw material for future worlds. You realise that everything, your bones, your phone, your morning coffee, was once part of one of these clouds. The first one you pass is the Orion Nebula, a glowing nursery visible even from Earth as a soft patch beneath Orion's belt. Up close, it's a sprawling cathedral of hydrogen and dust lit from within by a cluster of newborn stars. The mainstream fact: the Orion Nebula is about 150 light-years away and one of the brightest star-forming regions near Earth. The quirky tidbit: when astronomers first looked at it through telescopes in the 1600s, they thought it was smoke from distant celestial fires. Historians still argue whether the earliest sketches were accurate depictions or just artistic panic. Imagine seeing what looked like divine fog hanging in the heavens and not knowing it was literally the birthplace of suns. As you glide through, filaments of glowing gas twist around you like luminous seaweed in slow motion. The newborn stars hiss and hum, their radiation shaping the surrounding clouds into sculpted arches. Every few moments, one of these infant suns flares, clearing away the dust around it and revealing another patch of hidden brilliance. The effect is hypnotic, a galaxy perpetually painting and erasing itself. You're not just watching creation, you're floating through it. A little farther along the spiral arm, the nebulae grow darker. Here lie the Horsehead and the Pillars of Creation, names that sound poetic until you realise how brutally literal the processes are. These are regions where gravity pulls gas together until it collapses under its own weight, igniting nuclear fire. The mainstream fact: in the Eagle Nebula's Pillars of Creation, captured famously by the Hubble telescope, columns of cold hydrogen stretch several light-years tall, sheltering embryonic stars. The fringe tidbit: some scientists suspect those pillars might already have been destroyed by a nearby supernova thousands of years ago. We're just seeing them as they were, not as they are. Historians still debate whether the name Pillars of Creation is ironic, tragic, or perfectly cosmic. A photograph of something that may no longer exist, yet continues to inspire awe. You glide through that glowing dust and your mind fills with strange analogies. Each nebula feels like a cosmic recycling plant where nothing is wasted. Old starlight turned into new fuel, ancient atoms reassembled into fresh geometry. You imagine the ghost of some long-dead star whispering, "You're breathing me," and realise it's true. The calcium in your bones, the carbon in your skin, the iron in your blood, all forged in stellar cores long before Earth existed. The nebula doesn't just look beautiful, it's ancestral. The light here shifts constantly, sometimes a rich magenta, sometimes icy blue. Those colours aren't paint, there are the fingerprints of elements. Hydrogen glows red, oxygen green, sulfur deep orange. If you could hear them instead of see them, the galaxy would hum in chords, hydrogen's low drone, helium's faint harmony. Carbon's sharp, sweet trill. You can almost imagine the whole Milky Way as a symphony of invisible notes, with the nebula providing the string section, melodic, resonant, and a little melancholy. You pass through a dimmer region and notice something strange. A single, faintly glowing bubble expanding through the gas. A remnant of a supernova. The star that created it died violently, scattering shockwaves that ripple through the surrounding space. The light from that explosion might have reached Earth before humans even existed. The mainstream fact: supernovae like this forge heavy elements, gold, uranium, even the iodine in your thyroid. The quirky tidbit: some of the earliest Chinese astronomers recorded guest stars in the sky, sudden new points of light that appeared and faded over weeks. Historians still argue whether those were supernovae within our galaxy, or bright novae from nearby systems. Either way, it means ancient eyes once watched these same deaths unfolding in real time, mistaking them for omens or divine signals. The dust thickens again, blocking the view of distant stars, and for a moment, everything goes quiet. You're inside one of the Milky Way's darker lanes now, where light struggles to pass through. It's eerily serene, like wandering into a fog bank made of shadow. Astronomers call this interstellar extinction, a lovely phrase for something that sounds so final. But it's not death, it's privacy. These dark nebulae are places where light hides to rest, where stars prepare to be born unseen. It's hard not to respect that kind of patience. You think about how humanity first tried to map these clouds, long before spacecraft and radio telescopes. In 1919, a young astronomer named Edwin Hubble used photographs of such regions to show that spiral nebulae were actually separate galaxies, entire star systems far beyond the Milky Way. The irony, of course, is that his discovery made our galaxy feel smaller, not bigger. We weren't the universe. We were just one beautiful swirl among billions. You continue onward, past clouds that flicker like campfires seen through smoke. You can almost sense the life cycles unfolding: collapse, ignition, explosion, silence, each phase endlessly feeding the next. The Milky Way isn't a static sculpture, it's a living ecosystem, a breathing collection of stories told in light. And as you leave the nebula behind, the darkness ahead begins to sparkle again with the faint, disciplined glow of older stars. You realize you've just witnessed the galaxy's full circle of life. The same pattern that made the first suns now waits patiently to build the last. Somewhere in all that cosmic dust, perhaps, lies the recipe for the next home, the next civilization, the next being to look up and wonder, how small am I, really? You rise above the galactic disk now, just enough to take in its full breathtaking shape. From this vantage point, the Milky Way looks like a colossal whirlpool of light, its spiral arms stretching gracefully outward, warped ever so slightly at the edges. It's not the neat, textbook perfect pinwheel that astronomy textbooks once promised. It's alive, uneven, and full of asymmetry, as though the universe itself couldn't resist doodling outside the lines. The light doesn't just radiate, it ripples. You can see the subtle bending of the disk, a faint tilt that makes the entire galaxy resemble a gently curved vinyl record spinning in silence. The Milky Way, it turns out, has bad posture, and somehow that makes it feel more relatable. Scientists didn't always know this. For centuries, the galaxy was imagined as a flat, clean sheet of stars, an orderly disk governed by geometry. Then came radio astronomy in the mid-20th century, and suddenly we saw the warp. Hydrogen gas, mapped in long, sweeping curves, revealed that the Milky Way's outer edges twist like the brim of a hat left too long in the sun. The mainstream fact: this galactic warp likely formed because of gravitational interactions with satellite galaxies, especially the Magellanic Clouds. The quirky tidbit? The warp actually wobbles over time, processing like a cosmic hula hoop, completing one full wobble roughly every 100 million years. Historians still argue whether that graceful distortion means the Milky Way is being tugged apart or merely flexing in cosmic rhythm. Either way, it moves like something that's been alive for a very long time. You hover higher still, above the galactic plane, and notice something that few ever consider: a faint halo of light surrounding everything. It's not visible to the naked eye, but it's there, a tenuous sphere of gas, stars, and invisible matter enveloping the disk like a translucent cocoon. The halo stretches hundreds of thousands of light years into the dark, blending softly into intergalactic space. You realize suddenly that the Milky Way doesn't end where its light fades. It just becomes quieter, thinner, until the distinction between galaxy and universe starts to blur. Within that halo, old stars drift like ghosts, ancient metal-poor relics from the galaxy's youth. Some of them may predate the spiral arms themselves, leftovers from the chaotic mergers that built the Milky Way billions of years ago. You picture them as cosmic elders floating serenely in the galactic outskirts, watching the younger generations spin below. It's strange to think that while you're busy counting birthdays on Earth, there are stars out here celebrating ages measured in galactic revolutions. You begin to trace one spiral arm from its origin near the core, following the ribbon outward as it wraps the galaxy 2 or 3 times before fading into diffuse starlight. These arms aren't solid structures, they're waves of density, patterns that move slower than the stars within them. It's like traffic on a cosmic freeway. The cars, stars, move faster than the jam, the arm. The illusion of permanence is just that, an illusion. Every star in the galaxy will eventually drift out of its spiral lane, crossing into new neighborhoods over billions of years. You can almost laugh at the absurdity. Even galaxies experience rush hour. Somewhere between the arms, immense bubbles of emptiness yawn open, regions swept clean by past supernovae. The interstellar medium isn't uniform, it's patchwork shaped by explosions, collisions, and cosmic winds. You pass over one such cavity, the local bubble, a pocket about 1,000 light-years wide in which our solar system currently resides. The mainstream fact: astronomers believe the local bubble was carved out by a series of supernovae that occurred roughly 10 million years ago. The quirky tidbit: some researchers suggest that those explosions may have briefly affected Earth's climate, sprinkling trace isotopes of iron-60 into our oceans. Historians still argue whether humanity's earliest ancestors might have gazed up at slightly different stars because of that reshaped interstellar landscape. From this distance, you notice how the spiral arms pulse with energy. Star clusters ignite like city lights turning on at dusk, while other regions fade into shadow. The Milky Way feels less like a static object and more like a vast breathing organism. Every spark of light is a heartbeat, every nebula a lung. You can almost sense it inhaling hydrogen, exhaling radiations, and whispering through wavelengths too vast for human hearing. You tilt your view slightly and there it is, the central bulge glowing gold surrounded by the pale blue arms. It's astonishing how something so intricate could form from chaos. Gravity, a simple attraction between masses, has sculpted all of this over billions of years. No architect, no blueprint, just matter obeying math until beauty inevitably emerged. You can't help but grin. The universe seems to have an artistic streak. The halo catches your eye again, shimmering faintly with something you can't quite see, dark matter. At least that's what scientists think fills most of it. The visible stars and gas account for only a fraction of the galaxy's total mass. The rest is invisible, detectable only through the way it bends light and shapes motion. You get the uneasy feeling that you're floating inside a ghost, a structure made of unknown substance that doesn't shine, scatter, or interact with anything except through gravity. And yet without it, the Milky Way couldn't exist. The edges would fling outward, the arms unraveling into interstellar confetti. Astronomers still debate what dark matter actually is: exotic particles, primordial black holes, or something so unfamiliar it doesn't fit our current physics. The truth remains just out of reach, humming beneath everything like a low note in the universe's background score. You take comfort in that mystery. After all, some secrets should remain unsolved long enough for future generations to chase them. As you descend again toward the disk, the view shifts back into that familiar galactic band, dusty, luminous, infinitely intricate. You realize that from Earth we're trapped inside this very structure, peering outward like fish trying to describe the ocean. You can map, measure, and name the parts, but to truly see the Milky Way, you have to step outside yourself, out here, where the shape finally makes sense. It's both humbling and oddly reassuring. Even our galaxy, magnificent and ancient as it is, isn't perfect. It's warped, uneven, constantly tugged by the obscene hands. And maybe that's the secret symmetry of existence, that the most beautiful things in the universe aren't flawless. They're simply balanced enough to keep spinning. You hover in silence, feeling the faint gravity tugging from every direction, and for a moment the Milky Way looks perfectly calm. But of course that serenity is an illusion. Beneath the glow, something unseen is holding everything together, a kind of invisible scaffolding without which the galaxy would have long since flown apart. You can't see it, you can't touch it, but you can feel its effect. It's called dark matter, and it's the universe's favourite trick, the most abundant stuff in the cosmos that refuses to show itself. You take a slow, imaginary breath and focus on the numbers. If you gathered up every star, planet, and dust grain in the Milky Way, all the things that actually shine or reflect light, you'd still account for less than 15% of its total mass. The rest, roughly 85%, is dark matter, invisible, silent, yet undeniably real. The evidence hides in the galaxy's motion. The stars in the outer arms orbit far faster than visible mass alone could allow. By Newton's laws, they should have been flung into intergalactic space long ago. Something unseen keeps them tethered. That something is dark matter, quietly cradling the Milky Way in its gravitational grip like a parent holding a spinning toy. The mainstream historical fact: in the 1970s, astronomer Vera Rubin measured how quickly stars orbited in spiral galaxies and found that their rotation curves stayed flat instead of tapering off. Her observations offered the first strong proof that galaxies contain far more mass than meets the eye. The quirky tidbit: Rubin's data was so shocking that many of her peers initially dismissed it as an instrumental error, until they repeated her work and got the same results. Historians still argue whether dark matter's discovery should rank beside Copernicus and Newton as one of humanity's great perspective shifts. Either way, Rubin's quiet perseverance changed our understanding of the universe forever. You imagine the galaxy now as a luminous jewel set inside a vast, invisible cloud. The dark matter halo extends hundreds of thousands of light years in every direction, shaping not only the Milky Way's form but its fate. The visible stars are just decoration, like sugar sprinkled on top of a massive transparent sphere. If you could somehow light up dark matter, the galaxy would look more like a glowing bubble than a flat disk. It's disorienting to realize that the part we see is just the thin frosting on an unseen cake. The question, of course, is what it actually is. Scientists have proposed candidates ranging from weakly interacting massive particles, WIMPs, to sterile neutrinos to primordial black holes. None have been proven. Billions of dollars worth of detectors, buried deep underground, shielded from radiation, have waited for decades to catch a single dark matter particle bouncing off an atomic nucleus. So far, nothing. The universe, it seems, is content to keep its biggest secret under lock and key. Historians still debate whether dark matter is truly a thing, or merely a sign that our understanding of gravity itself is incomplete. Theories like MONDI, modified Newtonian dynamics, try to explain galactic rotation without invoking invisible matter at all, though their math occasionally resembles wishful thinking written in calculus. You float deeper into the halo, where visible stars fade and the darkness thickens. The emptiness here feels different, not vacant but saturated with potential. You can almost sense the hidden mass, a vast cosmic ghost pressing gently against your awareness. It's not menacing, it's patient. Dark matter doesn't collide or clump like ordinary matter. It simply passes through everything, shaping reality by its presence. It's gravity's silent partner, the sculptor behind the scenes. Without it, galaxies would never have formed at all. In the early universe, just after the Big Bang, ordinary matter was too hot and energetic to gather. It was dark matter, cool, stable, and invisible, that provided the gravitational seeds for structure. The Milky Way owes its very existence to something that refuses to be seen. It makes you wonder about the irony. Humanity spends so much time chasing visibility, trying to shine brighter, to be seen, yet the universe itself is mostly made of what hides. Maybe that's the lesson. What's invisible isn't always insignificant. In fact, it might be the only thing holding everything else together. The stars return faintly as you drift closer to the disk again, their light slicing through the dark matter like sparks in fog. Somewhere down there, physicists are building ever more elaborate experiments, cryogenic chambers, particle accelerators, orbiting observatories, all in the hope of glimpsing a trace of the unseen. Some even joke that dark matter might be laughing at us, slipping between our instruments the way shadows slip through fingers. You can't help but chuckle too. The idea that the universe is mostly composed of a substance that doesn't even acknowledge light feels like the ultimate cosmic prank. Still, there's poetry in it. If you think of the Milky Way as a grand tapestry, or the stars are the glittering embroidery, but dark matter is the loom, silent, invisible, indispensable. Its presence defines the pattern, even if you never see the threads. You glance outward, toward intergalactic space, and see the faint pull of other galaxies shimmering just beyond. The Andromeda Galaxy, our nearest large neighbour, glows softly 2.5 million light-years away, and between us stretches an invisible bridge, a shared halo of dark matter binding the two spirals together long before their visible edges touch. You imagine that unseen connection as a slow gravitational handshake, a silent promise that one day these galaxies will merge. Back in your current moment, you hover amid this sea of invisibility, awestruck by how fragile yet complete it all feels. You can't see dark matter, but its influence is written everywhere. In the orbits of stars, in the curves of galaxies, even in the structure of the entire cosmos. The universe hides most of itself from us, but it still leaves clues, like breadcrumbs scattered across infinity. And maybe, just maybe, that's the point. If the Milky Way revealed all its secrets at once, the wonder would vanish. Mystery, after all, is the gravity that keeps curiosity in orbit. You drift along the outskirts of the Milky Way now, where the spiral arms begin to blur into faint wisps of light. And for the first time in this long, quiet journey, you notice we're not alone. Hanging nearby like glowing lanterns in the dark are two smaller galaxies, our cosmic neighbours, the Magellanic Clouds. The large Magellanic Cloud looks like a ragged smear of light, soft and milky, while the small Magellanic Cloud trails behind it like a puff of fog. They're close enough to tug gently on our galaxy, but far enough to keep their distance, orbiting like loyal companions. You can almost imagine the Milky Way as a serene monarch surrounded by two mischievous courtiers, constantly flirting with the idea of collision. The Magellanic Clouds aren't just pretty smudges in the sky. They're full-fledged galaxies, smaller but full of life, their stars young and bright, their gas clouds fertile and wild. The Large Magellanic Cloud, or LMC, lies about 160,000 light-years away, and the Small Magellanic Cloud, or SMC, roughly 200,000. From Earth's southern hemisphere, they hang like twin freckles in the night, softly luminous even to the naked eye. Early sailors used them for navigation, calling them clouds, long before telescopes revealed their true nature. The mainstream historical fact, Ferdinand Magellan's crew officially documented them in 1519 during their circumnavigation of the globe, hence the name. The quirky tidbit: indigenous peoples of the southern hemisphere, long before Magellan, already had countless names for them, from the Maoris' Ao Nui, Great Cloud, to the Khoisan's Stars of the Lion. Historians still argue whether the European naming of these galaxies was an act of discovery or appropriation. Either way, they've been lighting human imaginations for millennia. You zoom closer to the LMC, and it feels vibrant, almost youthful compared to the stately Milky Way. Its stars crowd together in brilliant clusters, and nebulae bloom like rose petals across its span. The Tarantula Nebula dominates one corner, a sprawling web of pink and crimson gas so large it could swallow our entire solar system 1,000 times over. It's one of the most active star-forming regions in our local group of galaxies, a cosmic factory, where suns are born by the dozen. You hover near its edge, watching stellar nurseries ignite like lanterns underwater. If the Milky Way is middle-aged, the LMC is an energetic teenager with too much caffeine and no bedtime. The SMC, by contrast, feels quieter, less symmetrical. It's been tugged and stretched by gravitational forces for eons, leaving it warped and frayed around the edges. A trail of gas called the Magellanic Stream connects both clouds to the Milky Way, a filament thousands of light-years long that swirls around our galaxy like a faint ribbon. Scientists believe it's the debris of countless tidal interactions, bits of the cloud slowly being siphoned away by our galaxy's pull. It's oddly tender, in a cosmic way, like the long scarf of a dancer caught in another's orbit. You realise then that even galaxies have relationships, complex, messy, gravitationally codependent ones. They court, collide, merge, and sometimes devour each other. The Milky Way has already consumed several smaller galaxies in its past, their remnants lingering as faint streams of stars that wrap around the disk. Astronomers have mapped these relics, tracing the paths of stellar refugees long after their homes were torn apart. One of them, the Sagittarius Dwarf Galaxy, is currently being digested by our own, its stars stretched into a shimmering ribbon that loops around the Milky Way's halo. Historians still argue whether the term cannibal galaxy sounds more terrifying or endearing, depending on how poetic you're feeling. You move slowly now, past the clouds, watching how their faint light merges with the Milky Way's halo. The darkness between them isn't empty, it's threaded with invisible matter, dark and delicate, forming a cosmic bridge that links all three. It's humbling to realize how interconnected these systems are, gravitationally locked in a slow dance that's been unfolding for billions of years. Eventually, millions of years from now, the Magellanic Clouds will merge completely with our galaxy, adding their stars, gas, and memories to ours. Nothing in the universe ever truly disappears, it just gets redistributed. If you could speed up time, you'd see the Milky Way slowly drawing its companions inward, their graceful orbits tightening until they dissolve into the larger disk. You'd watch the Tarantula Nebula scatter its young stars into the galactic mix. You'd witness spiral patterns emerge, faint echoes of old collisions sculpting the Milky Way's future. And through it all, our sun would continue its patient orbit, blissfully unaware of the cosmic drama beyond its neighbourhood. You think about how, from Earth's southern hemisphere, humans still look up at those same clouds and feel something ancient stirring. A reminder that the sky isn't static, that the universe is full of neighbours, and that motion itself is a kind of beauty. There's an irony in it. The Magellanic Clouds appear still, but they're racing through space at hundreds of kilometres per second, pulled and reshaped with every passing eon. Even stability, it turns out, is just motion too slow for our eyes to see. Somewhere deep within the LMC, a cluster of newborn stars burns furiously, its ultraviolet light streaming into space. That light will travel 60,000 years before it ever reaches Earth, meaning that when you gaze at the clouds tonight, you're seeing them as they were when humans were still painting on cave walls. You smile softly. The galaxy has no urgency, it moves at the pace of memory. And as you drift back toward the Milky Way, you catch one last glimpse of those faint companions glowing behind you. Two small galaxies clinging to a larger one. Not parasites, not prisoners, but participants in a slow cosmic waltz that will one day unite them all. You can almost imagine the final dance billions of years from now, when their stars blend seamlessly into our own spiral. By then, no one will remember where one galaxy ended and another began. That's the secret truth of the cosmos. Everything you think is separate is already connected. The stars just take their time showing it. You linger on the edge of the Milky Way, staring into the deep darkness where even starlight begins to thin, and suddenly the stillness cracks open with a thought so large it swallows you whole. The Milky Way is doomed to collide. Not tomorrow, not next week, but inevitably, because gravity, that persistent matchmaker, never lets go. The Andromeda Galaxy, our nearest spiral neighbour, is already rushing toward us at about 110 kilometers per second. You could almost hear the faint cosmic drumroll, a promise written in momentum. The two galaxies are on a collision course, locked in a slow-motion embrace that will reshape them both forever. It's strange to think that from Earth's point of view, Andromeda looks so peaceful, a soft oval of light in the constellation of its name, visible on clear nights if you know exactly where to look. That gentle smudge is actually a behemoth, slightly larger than the Milky Way, containing roughly 1 trillion stars. If your eyes could detect ultraviolet and infrared light, Andromeda would stretch across the width of 6 full moons in the night sky. The mainstream historical fact: in 1924, Edwin Hubble proved that Andromeda wasn't a cloud within our own galaxy, but an entire galaxy in its own right, ending the great debate over the scale of the universe. The quirky tidbit: before Hubble's discovery, some astronomers called Andromeda a spiral nebula and believed it might even house alien civilizations sending mysterious radio signals, 19th century proto-sci-fi at its finest. Historians still argue whether Hubble's revelation or Copernicus's heliocentric model displaced humanity more completely from the centre of things. Now, nearly a century later, we know our two galaxies are drifting closer, drawn together by their shared halo of dark matter. You picture it, a cosmic slow dance that will take roughly 4 billion years to reach its crescendo. There will be no crash, no shattering like billiard balls. Instead, the stars will mostly pass between each other, separated by distances so vast that even direct collisions are rare. But the gravity of each galaxy will distort the other, pulling out long tidal tails of gas and stars, twisting them into ribbons that sparkle like spilled glitter. The Milky Way's neat spiral will stretch, warp, and bloom into something new. From your elevated vantage point, you can fast forward through cosmic time, watching it unfold. The first encounter tilts the Milky Way's disk, sending shockwaves of star formation rippling through the arms. Entire clusters ignite in brilliant bursts, temporary fireworks on a billion-year scale. Then, as the galaxies pull apart and swing back together, their cores begin to merge, each orbiting the other like two storm eyes spiraling inward. The night sky of some distant future Earth, or whatever replaces it, will blaze with the new constellations, Andromeda's stars, swelling until they fill the heavens. Imagine a horizon where the Milky Way stretches upward, colliding head-on with another galaxy's heart. That would be beauty mixed with the terror of scale. Eventually, the two galaxies will fuse into one elliptical giant, an entirely new structure often nicknamed Milkomeda or Milkdromeda, depending on which astronomer had more coffee that day. The name sounds playful, but the outcome is profound. The swirling disk will smooth into a glowing egg-shaped mass of stars. The central black holes, our Sagittarius A and Andromeda's own monster, will spiral together and merge, releasing a final gravitational roar that ripples across space-time. It's the kind of event that LIGO's distant descendants might record as the loudest cosmic chirp in history. You can't help laughing softly. The idea that the galaxy you've been admiring this whole time will one day vanish into another seems almost rude. After billions of years of elegant spinning, the Milky Way will become part of something else. Larger, slower, more luminous, yet that's the cosmic way. Creation and destruction are just two words for the same process: transformation. You drift through a mental simulation of the aftermath. New stars form from the collision's compressed gas, blazing briefly before burning out. Planetary systems are flung into intergalactic space, while others settle into stable orbits in the new galaxy's calm center. The solar system, if it still exists, might drift to a quieter orbit or be ejected entirely, a tiny refugee wandering the darkness. Historians still argue whether our descendants, if any survive that long, will even recognize the night sky. Every familiar constellation will dissolve: Orion, Ursa Major, Cassiopeia, all erased. The stars will have moved on, their patterns rewritten by time. But here's the oddly comforting part. The odds of any two stars colliding during that merger are almost zero. The space between them is so immense that even in the most crowded regions, they're more likely to dance around each other than crash head-on. The spectacle will be dazzling, not destructive, a ballet of light rather than a demolition derby. You imagine standing on some distant moon billions of years from now, watching Andromeda swell until it fills half the sky, the Milky Way's spiral arms stretching to meet it. The sky would shimmer with arcs of blue and gold, rivers of starlight curling in slow motion. It would be, quite literally, the most beautiful apocalypse imaginable. For a moment, you think about how temporary everything is, even galaxies. They're born, they age, they merge, and eventually they fade. The universe itself will one day grow cold and dark as its stars exhaust their fuel. But between now and that far horizon of entropy, there's so much movement, so much artistry. Maybe impermanence isn't something to fear. Maybe it's the mechanism that makes beauty possible. After all, without motion, without change, nothing would sparkle. You turn back toward the present, where the Milky Way still spins gracefully, unaware of its future collision partner. The distance between them may be shrinking, but the timeline stretches far beyond human comprehension. For us, the sky tonight will look exactly as it always has: calm, familiar, infinite. Only the faintest whisper of Andromeda's approach drifts through radio telescopes, a subtle blue shift in its light. The grand merger is already written in the laws of motion, but we have billions of years to admire the before picture. As you drift in notes, one last thought flickers. Maybe the collision isn't an ending at all. Maybe it's a reunion, two ancient selves remembering that they were once born from the same cosmic fabric, drawn inevitably back together. And if the universe can be patient enough to let that happen, maybe you can too. You drift back toward the familiar territory of our spiral arm, the Orion Spur, the quiet district of the Milky Way that we call home. And for the first time in this vast journey, you feel something like belonging. After watching galaxies collide, it's comforting to settle in the cosmic equivalent of the suburbs, steady, bright, and mercifully uneventful. This region isn't the galaxy's showiest address. It's not near the radiant chaos of the core, nor lost in the desolate outskirts where light fades into nothing. It's the in-between, the gentle middle ground. And somehow, that makes it the perfect cradle for life. The Sun orbits about halfway out from the galactic centre, roughly 26,000 light-years away. That distance puts it in what astronomers sometimes call the galactic habitable zone, an area not too crowded, not too barren. Goldilocks logic scaled up to infinity. The mainstream fact: regions too close to the centre are bombarded by radiation and supernovae, while those too far out lack the heavy elements needed to form planets. The quirky tidbit: some scientists have proposed that life in the galaxy could form a galactic club, a kind of cosmic neighbourhood association, and that we're currently in a quiet cul-de-sac waiting for the invitation. Historians still argue whether the absence of alien contact means we're isolated by geography, by time, or by our own technological infancy. Whatever the reason, this spot, mid-arm, mid-distance, is likely one of the safest, most stable places a thinking species could hope to emerge. You zoom in now, back toward the thin disk where our star sits. The light softens, filtered through faint clouds of interstellar dust. You can almost hear the hum of order here, the solar system tracing its calm path through the galactic sea. Compared to the violence of the core or the emptiness beyond the rim, this region feels domestic, lived in. It's the difference between camping near a volcano and sipping tea by a quiet lake. The thought makes you smile. The Milky Way may span 100,000 light-years, but the fraction that sustains us, this tiny, invisible bubble of warmth, is just a few hundred light-years wide. Within it lie stars similar to the Sun, planets orbiting in tidy ellipses, and perhaps other small worlds wrapped in oceans and clouds. You can't see them all, but the statistics whisper possibility. Astronomers estimate there could be tens of billions of Earth-like planets in our galaxy alone. That's a number so huge it becomes nonsense, until you remember that even one, ours, was enough to start asking questions. You drift past the solar neighbourhood tracing the web of nearby stars: Alpha Centauri, Barnard's star, Wolf 359, Tau Ceti. They're ordinary suns, yet each one could host something extraordinary. You think of how humans have already sent probes: Voyager, Pioneer, New Horizons, each carrying small messages outward, like cosmic notes slipped under a neighbour's door. Those spacecraft travel at tens of thousands of kilometres per hour, yet even at that speed, reaching the nearest star would take over 70,000 years. The distance between hello and reply in this neighbourhood could outlast civilizations. Still, the desire to send the message persists. Maybe it's because deep down, life recognises itself as part of something larger. This galaxy's suburbs might be quiet, but they aren't lonely. Between the stars runs an invisible network of potential, signals, light, gravitational whispers, all humming with the same physics. You imagine that every advanced world, wherever it hides, eventually reaches this same moment, staring up and wondering whether the silence is emptiness or invitation. The serenity of this region hides the remnants of past dramas. Every element in your body, the calcium in your bones, the oxygen you breathe, was forged in older generations of stars right here in the galactic neighbourhood. When they died, they scattered their riches across space, seeding the raw materials for planets, oceans and nervous systems capable of awe. That's the cosmic irony. The quiet beauty of your world was built by violence you can't even imagine. You're literally the piece that followed explosions. Historians still argue whether our position in this middle zone is coincidence or necessity. Some claim life could have emerged anywhere given enough time. Others argue that our exact coordinates, far from the radiation storms, close to enough heavy elements, are a narrow window in the galactic lottery. If the Sun had formed closer to the core, the sky might blaze with so many stars that night would never fall. Move it further out, and the early solar system might never have had enough iron to build rocky planets. Whatever the truth, the odds of existing right here, right now, are absurdly small, and yet, here you are. As you float above the Orion Spur, you see it stretching outward like a luminous tendril curling through the dark. Star clusters glitter along its length. The Pleiades, the Hyades, the young cluster, NGC 2232 shining faintly through the haze. Between them lies the familiar patch of the night sky we call home. It's humbling to think that from a galactic perspective, all of human civilization, every city, every story, fits inside a speck smaller than a molecule in this arm of stars. But maybe that's what gives the Milky Way its balance. The galaxy doesn't need every corner to be brilliant. It needs quiet places too, rooms where complexity can grow slowly, sheltered from chaos. The suburbs of the Milky Way are like those small towns you drive through without noticing, unaware that something miraculous might be growing there. You watch the sun make its slow, patient loop around the galactic beater, dragging Earth and its moon behind it. There's no drama here, no cosmic collisions or roaring quasars, just stability. And in that stillness, life gets the time it needs to wonder, to build telescopes, to dream of other skies. You realize that being small in such a vast structure isn't a disadvantage, it's protection. The light from billions of distant stars glimmers faintly across the galactic plane. Somewhere out there, others might be watching too from their own spirals, wondering if anyone else knows this same feeling. The Milky Way may be immense beyond comprehension, but in this small, quiet corner, it has achieved something extraordinary. It's learned to look back at itself. You float in the stillness of the Orion Spur, the cosmic suburbs glowing softly below, and for the first time you tune your ears, not for light, but for sound. Of course, there is no sound in space, only vibration, radiation, and the faint whisper of electromagnetic noise. But if you could translate the galaxy's signals into something you could hear, the Milky Way would hum like an orchestra tuning in the dark. Beneath the steady tone of starlight, there's another rhythm, one made by us. Humanity has been broadcasting into this void for barely a century, and yet our radio waves are already expanding in a fragile sphere 100 light-years wide. You imagine it as the faint bubble of static wrapped around the sun, expanding outward at light speed, the sum total of our presence in the galaxy so far. Inside that bubble are greetings and gossip, music and mayhem, Morse code, news reports, old sitcoms, lost transmissions of lunar landings, emergency broadcasts even of songs. The mainstream fact, our earliest intentional interstellar message, the 1974 Arecibo transmission, was sent toward the globular cluster M13, a patterns of binary code describing DNA, our solar system, and a little stick figure human. The quirky tidbit? M13 is 25,000 light-years away, so our message won't arrive there until the year 27,000, and any reply would take just as long to return. Historians still argue whether that was a bold step toward cosmic communication or an expensive way to send junk mail into eternity. You imagine those signals passing through dust and plasma, stretching and scattering across light years. Maybe some of them will wash over alien receivers, if any exist, centuries from now, long after humanity has forgotten the shows and songs it sent. The thought is both thrilling and absurd. Somewhere out there, an alien civilization could one day intercept a rerun of a 50s commercial for toothpaste and think it represents the height of Earth's art. You can't help but grin. The universe must find us delightfully ridiculous. Still, the act of sending is itself a kind of prayer. You think of all the ways we've tried to announce ourselves: radio pulses, plaques, probes. The Voyager golden record drifts far beyond Pluto now, etched with music, greetings in dozens of languages, and images of life on Earth. The mainstream fact. Carl Sagan and his team included sounds from nature, the roar of waves, the crackle of fire, the laughter of a child. The fringe tidbit. The record also carries a hidden hum of data, including a drawing of a naked man and woman that some critics at the time thought too indecent for aliens. Historians still argue whether that little engraving was naive optimism or an honest introduction. Either way, it means that humanity's first impression across the cosmos includes both Bach and a polite nude selfie. You drift farther from the sun, listening in your imagination to the galactic noise. Pulsars tick like metronomes, quasars rumble in the far distance. Cosmic microwave background radiation hums softly, a faint static older than galaxies themselves. And faintly, just faintly, you can detect the whispers of human curiosity layered on top of it all. For a young civilization, we've been loud. SETI telescopes listen in return, scanning for structured patterns amid the chaos of cosmic radio. So far, they've found none. The silence has a weight to it, a mystery that has haunted generations of thinkers. You recall the Fermi paradox. If intelligent life is common, why haven't we heard from anyone? Historians still debate whether that question says more about the cosmos or about us. Maybe advanced civilizations hide, fearful of predators. Maybe they've transcended material communication altogether. Or maybe we simply haven't been listening long enough. After all, Our century of broadcasts is less than a heartbeat in galactic time. For all we know, someone out there sent their greeting 1,000,000 years ago, and it's still en route, passing unseen through the halo of the Milky Way. You think about what it would mean to receive that first signal, a burst of order amid the noise. Perhaps it wouldn't be words, just a repeating mathematical pattern, a cosmic hello. The moment would change everything. Religions, sciences, philosophies, all rewritten in a single blink. And yet there's an equally profound beauty in the silence itself. The quiet reminds us that even if no one answers, the act of calling out matters. It means we're awake. The longer you listen, the more the silence turns into music. You realise that the Milky Way itself is a form of communication. Every photon from every star carries information about its origin, temperature, age, motion. When astronomers study that light, they're reading the galaxy's autobiography written across 10 billion years. The stars speak. It's just that their language is physics. You glance back at Earth, that pale dot humming with invisible signals. Our radio bubble is laughably small compared to the galaxy's 100,000 light-year span, yet it represents something remarkable, a species daring to make noise in an indifferent universe. Even if no one ever hears us, our presence is written into the cosmic background, mingling with the hiss of ancient starlight. For every cry of loneliness, there's an answering echo of existence. The cosmic scale of our communication becomes humbling. You imagine future generations sending light sails across the interstellar gulf, carrying AI emissaries, or building enormous radio arrays on the moon. Humanity will keep trying, not because it expects a reply, but because reaching outward is what consciousness does. The galaxy is vast, but not voiceless. Every act of curiosity, every broadcast, every quiet hello flung into the dark adds another note to its invisible song. You realise then that the Milky Way isn't silent at all, it's just patient. It listens on timescales we can't yet imagine. Our messages are still young, our language still forming. But given enough time, the galaxy will answer. Maybe not with words, maybe not even with life, but with the realisation that everything we've ever sent, every pulse of energy, every heartbeat of technology has become part of the Milky Way's own rhythm. You close your eyes, letting that thought settle like starlight fading into static. The silence isn't loneliness, it's a pause between verses. Somewhere out there, the next note is already on its way. You turn away from the hum of humanity's faint signals and drift once more into the broader swirl of stars, this time focusing not on what is, but on what was. Every light in the Milky Way is an artifact, a story already finished, and the galaxy itself is a kind of museum, each star an exhibit in an ongoing excavation of cosmic history. Astronomers call this field galactic archaeology, a poetic term for what is, in essence, the art of digging through light. Instead of shovels, they use spectrographs. Instead of bones, they uncover elements and motion. Each chemical fingerprint tells them when and where a star was born, and slowly, piece by piece, they reconstruct how this grand spiral came to be. From your vantage point above the disk, the Milky Way looks serene, but its past is anything but peaceful. 13 billion years ago, it began as a swarm of smaller galaxies colliding and merging, their stars thrown together in chaos. Those early generations burned fast and bright, filling space with the heavy elements that later formed planets, oceans, and eventually creatures like you. The mainstream fact, the oldest known stars in the Milky Way's halo date back over 13 billion years, almost as old as the universe itself. The quirky tidbit, some of those ancient stars contain almost no metals at all, meaning they were born before the periodic table had much variety to offer. Historians still argue whether these relics are true population 2 stars or fragments from even earlier galaxies that didn't survive the Milky Way's youth. Either way, they are the galaxy's grandparents, quietly orbiting above the bright modern disk like watchers of time. You float closer to one of them, a faint reddish point of light older than language, older than continents. It glows with the faint dignity of age. Its spectrum reveals the barest traces of carbon and iron, suggesting it was born when the universe was barely 1 billion years old. To the naked eye, it looks ordinary. Through science, it becomes a time machine. Each photon it emits carries information about an era when galaxies were still learning how to spin. You can almost hear it whisper, patient and wise, "We were here before everything settled down." Below, younger stars race through their orbits like restless children. The contrast is striking. Above, the slow ancient halo. Below, the frantic traffic of the disk. Astronomers study these motions using what they call stellar kinematics, mapping velocities to trace where each star came from. When plotted together, those paths reveal ghostly streams looping around the Milky Way, remnants of smaller galaxies that were long ago absorbed. The Sagittarius Stream, for instance, is one such relic, the shredded remains of the Sagittarius dwarf galaxy that the Milky Way has been consuming for billions of years. You watch its faint arc of stars wrap around the galaxy like a scarf of lost history. The more you look, the more you realize that the Milky Way is not a single coherent entity, but a palimpsest, a layered document written over itself countless times. Beneath the visible spiral hides the imprint of every collision, every burst of star formation, every ripple of gravitational influence. If the galaxy were a person, it would carry scars upon scars, each one beautiful in its own way. You drift toward the thick bulge at the center and see how densely packed the stars are there. The ones closest to Sagittarius A move in tight, frantic ellipses, while farther out the older populations orbit more sedately. Astronomers study the composition of these regions to learn how the galaxy's core evolved, whether it grew gradually through star formation or rapidly through mergers. Historians still argue whether the Milky Way's current spiral arms were sculpted by collisions with smaller galaxies or by internal instabilities in its disk. Whatever the mechanism, the result is something like sedimentary rock, layers of cosmic events stacked neatly through time. You shift your gaze outward again to the halo. Sparse though it is, that outer shell contains clues to the galaxy's most ancient days. Some of its stars orbit backwards relative to the main disk, like salmon swimming upstream. They were captured from smaller galaxies, carrying with them their unique chemical signatures, a different blend of metals, a distinct rhythm of creation. To the trained eye, those stars stand out instantly, their spectra betraying their foreign birthplaces. It's as if the Milky Way wears jewellery made of its past conquests. The tools that uncover this history are surprisingly elegant. Telescopes like Gaia, Hubble and the Vera Rubin Observatory collect torrents of diapour, positions, motions, compositions, transforming the sky into a living spreadsheet of time. Computers sift through billions of stars, finding patterns invisible to human intuition. Out of chaos emerges chronology. The Milky Way stops being a backdrop and becomes a story, one that begins long before Earth cooled and will continue long after it fades. It's impossible not to feel a strange intimacy with it. The same elements astronomers measure in those ancient stars also pulse within your blood. Iron from a supernova that died before the sun was born now sits quietly inside you, helping to carry oxygen through your veins. You're literally an archaeological artifact, made from the debris of stellar generations. It's humbling to think that the Milky Way's history isn't just around you, it's beside you. As you drift between those old halo stars, their light like embers in the dark, you begin to see time itself differently. The galaxy doesn't care about centuries or civilizations, it measures in revolutions and collisions. What feels ancient to you, a pyramid, a mountain, is a blink to it. Yet somehow, by studying its layers, humans have managed to piece together billions of years of narrative from mere points of light. The galaxy may not remember you, but you remember it, and that's enough to bridge the gap. You float back toward the disk, the warm glow of younger stars washing over you. The Milky Way's story is still unfolding, new chapters being written in hydrogen and gravity. Maybe, in some distant epoch, future astronomers will look at the faint trace of our sun's orbit and call it one more thread in the galaxy's archaeological tapestry, a brief, bright moment when a small planet looked up and began to read the stars. You're still drifting through the spiral arms when a strange thought crosses your mind. What if everything you've seen so far is a kind of illusion? You blink, and the Milky Way wavers slightly, like a reflection rippling on the surface of a pond. The galaxy isn't lying to you exactly. It's just that your eyes, your atmosphere, and even your expectations are filters, bending truth into beauty. When you look up from Earth and see that pale, misty band stretched across the sky, you're not seeing the Milky Way as it is. You're seeing a flattened, dust-obscured projection of what it lets you see, and the galaxy's reality is far more complex, far stranger, and in its own way far more honest. From the ground, the Milky Way appears as a faint ribbon of light crossing the night. You've probably stood beneath it before, half asleep, marvelling at its soft glow. What you were really seeing was the combined light of billions of distant stars, blurred together by the air above you and the limitations of human sight. In truth, it's not a ribbon at all. It's a cross-section of the disk. Viewed from inside, you live inside a glowing pancake of stars, looking edge-on through its densest region. The illusion makes the galaxy look like a streak, when really it's all around you, a vast three-dimensional sea. The mainstream fact, the band of the Milky Way is brightest toward the constellation Sagittarius, because that's where the galactic center lies, thick with stars and dust. The quirky tidbit, some ancient astronomers thought the band was the residue of sunlight trapped in the sky, a kind of celestial spill that couldn't drain away. Historians still argue whether Aristotle himself believed it was an atmospheric phenomenon rather than a structure of stars, proof that even the greatest minds sometimes mistake the entire galaxy for bad weather. You pass through one of those dusty regions now, and suddenly the illusion deepens. Dark streaks slash across the stars like smoke, blocking out light entirely. From Earth, these look like empty patches of sky, but in reality, they're dense clouds of carbon and silicate grains, thick enough to obscure even entire clusters behind them. The Great Rift, that dark lane splitting the Milky Way's band, is one of these cosmic blinds. It hides much of the galactic core from human eyes, giving our night sky its mottled pattern of brightness and shadow. You drift through it like a ghost, the starlight dimming into a warm amber fog. Astronomers have spent centuries trying to peel back this veil. At first, telescopes could only see what visible light allowed, the bright stars nearby and little else. But once they began studying other wavelengths, in radio, infrared, X-ray, the Milky Way changed shape entirely. What was once a delicate ribbon became a vast dynamic system, filled with unseen structures, jets, filaments, balls, and magnetic fields twisting like invisible roots. You realize that every photograph of the galaxy is both a revelation and a lie, true within one wavelength, false in all the others. Reality, it seems, depends on which light you choose to trust. You hover above a region where the illusion collapses completely. Infrared light reveals an entire city of stars hidden behind dust, glowing faintly like embers beneath a blanket. It's disorienting to realize how much of the galaxy's structure is concealed from view, even now. Historians still argue whether early stargazers, who could see only the visible band, might have been luckier in a way. Ignorant of what they couldn't perceive, they filled the gaps with mythology. We, armed with instruments that reveal everything, have replaced myth with measurement, but perhaps we've lost a little poetry along the way. You drift outward again, this time looking back at the Milky Way from a higher vantage point. Its spiral arms flare softly, glowing with the combined light of countless suns. From this height, the illusion is reversed. Now the galaxy looks too simple, too two-dimensional. You can't see the depth, the turbulence, the internal drama that gives it life. It's as if you've swapped one kind of blindness for another. You smile at the irony. The universe keeps teaching the same lesson. Everything depends on perspective. There's another kind of illusion woven into this view. Time. Every star you see sends light that took years, centuries, even millennia to reach you. When you gaze at the Milky Way, you're not seeing a galaxy now. You're seeing a composite of countless different moments. Some of those stars may already be dead. Some haven't yet existed when their light left. The Milky Way is a mosaic of ghosts and futures, all shining at once. It's the ultimate time-lapse photograph, one where every frame overlaps and refuses to end. The more you stare, the more the line between reality and perception blurs. You remember that Earth's atmosphere itself bends starlight, shimmering with temperature layers that distort the view. Even the telescopes above the air, Hubble, James Webb, see through their own filters and assumptions. The Milky Way doesn't present itself plainly. It demands interpretation. Every image of it, every artist's rendering, every colour-enhanced photo is a translation, a poem made of photons. And maybe that's okay. Maybe illusion is how the universe lets small creatures like us grasp the ungraspable. Our minds can't hold the full truth, so the cosmos offers it in pieces. A bright streak here, a shadow there. Enough to hint at infinity without overwhelming us. When you lie under the stars and see that pale river of light, you're not being deceived, you're being invited. The Milky Way is showing you the most it can within the limits of your biology, whispering, this is what you can handle for now. As you leave the dark lane behind, the stars brighten again, and the galaxy resumes its familiar shape. Comforting, imperfect, magnificent. You think about how every illusion, once decoded, reveals a deeper truth beneath it. The Milky Way may not look the way it truly is, but in your perception, it becomes something even more profound, a bridge between the physical and the poetic. You see it not just with your eyes, but with your imagination. And that, perhaps, is the most beautiful illusion of all. You stay suspended between the galaxy's luminous bands, the faint haze of starlight brushing against your awareness like static, and your mind wanders to the stories people have told about this shimmering stripe in the sky. Long before astronomers charted its rotation curves or named its arms, humans named its soul. Across continents and centuries, the Milky Way has been a mirror, reflecting whatever a culture most cherished or most feared. Every civilization looked up at that soft glow and saw something of itself written there. The science is impressive, but the myths are older and maybe a little truer in their own way. You start with the Greeks, of course, because the very name Milky Way is their invention. According to one myth, Zeus placed his infant son Heracles at the breast of his sleeping wife Hera, so the child could drink divine milk and gain immortality. Hera woke, startled, and pushed him away. Her milk spilled across the heavens, forming the Galaxius Kyklos, the Milky Circle. It's a strangely domestic origin story for something so vast, a cosmic accident, a celestial mess. The mainstream historical fact, the Greek term galaxy literally comes from gala, meaning milk. The quirky tidbit? Some ancient scholars thought the Milky Way wasn't divine spillage at all, but the result of the sun's annual journey, leaving a luminous trail behind it, like cosmic exhaust. Historians still argue whether Aristotle truly believed that or simply enjoyed confusing his students. Far from the Mediterranean, other peoples told different tales. The Mayans saw the Milky Way as the world tree, its roots descending into the underworld and its branches holding the heavens aloft. Along its path, they traced the journey of souls, guided by constellations shaped like crocodiles and serpents. To the Norse, it was the road to Valhalla, the Vetrab route or Winter Way, a frozen bridge for fallen warriors. In China, it became the Silver River, separating the star-crossed lovers Jinu and Niulang, who could meet only once a year when magpies form a bridge across the stars. You can almost hear the sadness in that story, the timeless ache of distance that even galaxies seem to understand. You drift slowly along the band, hearing echoes of language in the light. The Persian astronomers called it Kehkashan, the roving palace. The ancient Egyptians imagined it as a heavenly Nile, mirroring their own sacred river. The San people of southern Africa saw it as a trail of ashes left by celestial hunters. Every version has the same heartbeat. People trying to locate themselves in something unfathomable. They couldn't measure it, so they mythologized it, and in doing so they measured something deeper, their own longing. From above, you can see why the story's stuck. The Milky Way arcs perfectly across the dome of the night, bisecting heaven and horizon. It looks deliberate, as if drawn there by an unseen hand. And though you know the truth that it's just the view from inside a spiral disk, the effect is still sacred. You realize that mythology and astronomy are not enemies. They're just two ways of describing wonder. One uses metaphor, the other uses math. Both begin with someone staring upward, asking what is that? Historians still argue whether myth helped or hindered early science. Some say it binded us to the physical reality of the stars. Others believe it was the necessary first step, the emotional scaffolding that made curiosity possible. You decide both are true. Myths are the galaxy's first data sets, observations encoded in story form, preserved through generations long before telescopes existed. They told people when to plant crops, when to travel, when to fear the dark. The Milky Way was the calendar, the compass, and the map of memory all at once. As you drift through the faint light of the galactic plane, you can almost see how the stories overlap, forming a human constellation of their own. Different continents, same impulse, to connect the glittering chaos into meaning. The same star cluster that formed Hera's spilled milk also served as the Mayans' sacred crocodile, the Egyptians' celestial river, the Navajos' Yekai's Daha, the path of spirits. It's astonishing how the same strip of light could contain so many interpretations, yet each of them, in its own way, describes connection. Every myth is a rope thrown upward, tying humanity to the sky. You think of modern times, of light pollution smothering that glow in most cities. Millions of people grow up without ever seeing the Milky Way directly, relying on photographs to imagine what their ancestors took for granted. Maybe that's why space art, planetariums, and even YouTube exist, to restore that lost intimacy. We've replaced campfire myths with pixel constellations, but the purpose is the same, to remember our scale and our story. You smile, thinking about how the galaxy has always inspired both awe and laughter. In one Aboriginal story, the Milky Way began when a spirit being shook a bag of ashes across the sky. In another, it's the track left by an emu running through the heavens, its shape still visible in the dark patches between the stars. These aren't errors, they're interpretations. To call them wrong would be to miss the point entirely. Science explains how the Milky Way shines. Myth explains why we can't stop looking at it. You tilt your view downward, toward Earth, and imagine all the different cultures beneath that same arc of light. Every language, every religion, every story, all orbiting the same truth, each version refracting the same wonder through a different lens. Maybe that's the hidden symmetry of it all. The Milky Way isn't just a galaxy, it's humanity's oldest shared experience. Before borders, before telescopes, before even written words, there was that streak of light reminding us that we belong to something enormous. You exhale, slow and steady, the starlight shimmering against your breathless awareness. Science might tell you that the Milky Way is made of hydrogen, dust and gravity, but myth reminds you that it's also made of yearning, imagination and love. Perhaps both descriptions are true, and perhaps neither could exist without the other. You linger at the rim of the Milky Way now, where the glitter begins to thin and the black between the stars grows bolder. The light here feels stretched, so faint it almost dissolves. You're standing, metaphorically speaking, at the galaxy's edge, the place where belonging starts to blur into the vast in-between. From this vantage point, you finally see how the Milky Way tapers, the disk thinning until it vanishes into the void, the spiral arms unravelling into wisps of stray stars. It feels like looking over the railing of a ship into endless ocean, that haunting mixture of fear and wonder that always comes when the map runs out. The galaxy's edge isn't a sharp line, it's a gradient. Astronomers define it differently depending on what they're studying: stars, gas, or dark matter. The visible disk stretches for about 100,000 light-years, but the faint halo of hydrogen and invisible matter extends far beyond that, perhaps 200,000 light-years in radius. The mainstream fact, recent research using Hubble and the Hubble Cosmic Origins spectrograph, suggests the Milky Way's gaseous halo may be as massive as all its visible stars combined. The quirky tidbit, that halo glows faintly in ultraviolet light, making our galaxy look a bit like a bioluminescent jellyfish in the cosmic deep. Historians still argue whether this outer region should count as part of the Milky Way or as the beginning of intergalactic space. You suspect the distinction is mostly human. It's all the same sea, after all. You drift just beyond the last concentration of stars into that dim region where gravity's pull weakens. Out here, the Milky Way looks delicate, like a glass disc suspended in darkness. Its spiral arms glow with faint blue light from young stars, while the core burns a rich gold. Around it, the dark matter halo hums silently, unseen but omnipresent, a vast cocoon holding everything in place. You can almost feel it breathing, if galaxies could be said to breathe. It's hard not to think of the Milky Way as alive, its edges expanding, its stars being born and dying, its outer halo absorbing lonely travellers drifting too close. Out here, far from the bustle of the inner arms, individual stars become lonely outposts. Some of them are runaways, flung outward by gravitational slingshots near black holes or supernova explosions. They travel hundreds of kilometers per second, exiles of celestial mechanics. You imagine one of those solitary suns racing forever into the dark, its planets, if it has any, unaware that they've been cast adrift. The thought makes you feel both awe and sympathy. Even stars, it seems, can lose their homes. You turn back toward the disk and notice faint streaks cutting through the halo. Tidal streams, the torn remnants of smaller galaxies that ventured too near and were stretched into filaments. The Sagittarius stream curls gracefully around the Milky Way like a ribbon, while the Antlion II dwarf galaxy hides behind our disk, almost invisible. You realise that the galaxy's edge isn't quiet, it's an archaeological dig, a scrapbook of collisions. Historians still argue whether the Milky Way's halo is more like a graveyard or a nursery, a place where old structures dissolve or where new ones take shape from their ruins. The truth, as usual, is probably both. You glance beyond the halo now, into what looks like pure emptiness, but even the void is busy. Intergalactic space hums faintly with photons left over from the Big Bang. Cosmic rays streak through, ancient and restless. A few rogue planets, unattached to any star, wander here too, cold, black and silent. You imagine them drifting forever, unlit yet persistent. The universe seems to love persistence. The Milky Way from this distance is heartbreakingly beautiful. Its spiral arms glow like the petals of a luminous flower, the core shining at the center like a candle protected by glass. If you tilt your head, you can see how the edges warp slightly upward and downward. That same subtle twist discovered by radio astronomers decades ago. You remember from before the Milky Way's bad posture. And now it looks almost graceful, like a dancer caught mid-turn. You feel an irrational desire to reach out to steady it, even though you know that would take more strength than every star inside you could muster. There's a silence out here that feels ancient, as though this edge has been waiting for someone to notice it. The stars of the outer disk rotate slower than those near the center, their orbits stretched and elongated by the galaxy's mass distribution. They move through time differently, each completing a full revolution only once every billion years or so. If you could hover here forever, you'd watch the spiral arms shift subtly, the disk's shape evolving over epochs. You'd see new stars flicker to life and old ones fade into embers. The edge of the galaxy is where impermanence and eternity shake hands. You imagine the sun's faint orbit deep inside that glowing whirl, a tiny bead in an enormous wheel. From this distance, our entire solar system is invisible, less than a whisper in the cosmic noise. Yet that's where all your memories, your species, your oceans, and your stories exist. It's humbling and strangely comforting to realize that everything familiar is tucked safely within this larger organism, sheltery beneath its spiraling arms like a bird's nest hidden in a vast tree. You turn your gaze outward once more, beyond the Milky Way's final stars. The darkness here isn't oppressive. It's rich, full of possibility. Ahead lie other galaxies, distant and luminous, scattered like lanterns across the cosmic ocean. You can already sense their pull, faint but insistent, the gravity of other worlds calling to you. But before you drift away, you take one last look back at the Milky Way, your home, your mother spiral, your improbable cradle of consciousness. It gleams quietly in the dark, a reminder that even edges are beginnings in disguise. You take a slow, steady breath, if breathing were possible out here, and finally turn your gaze beyond. The Milky Way fades behind you like a memory, its spiral arms dimming into the darkness, and ahead lies the true scale of what it belongs to. For all its splendor, our galaxy is just one of billions, scattered across the observable universe. Each one an island of light adrift in a cosmic sea so vast that even the word infinite feels insufficient. You're no longer inside the Milky Way, you're outside of belonging of itself, hovering where perspective becomes both terrifying and liberating. Directly ahead floats the Andromeda Galaxy, its delicate whirlpool of stars glowing like a city seen across a great ocean. You know its story already, how it's rushing toward us for that inevitable dance. But from here, it's serene, luminous, and impossibly grand. Its spiral arms glimmer faintly blue, filled with hot, young stars while its core burns a golden white. If you could stretch your hand across the void, the light brushing your fingertips would be 2.5 million years old, leaving Andromeda when Homo habilis was still learning to use tools. Every photon that reaches you from it is both ancient and immediate, a cosmic postcard mailed long before humanity existed to read it. The mainstream historical fact: Edwin Hubble confirmed in Night 24 that Andromeda lay far beyond the Milky Way, proving that the universe was composed of countless galaxies, not just one. The quirky tidbit: when he sent his groundbreaking paper to publication, he added a modest footnote saying, "It appears probable that," the understatement of the century. Historians still argue whether Hubble truly grasped, in that moment, that he had just expanded the size of the known universe by orders of magnitude. It's comforting to imagine he didn't, that he was simply another curious mind making an observation, unaware that his small act of measurement would forever change humanity's sense of place. You drift past Andromeda now, noticing her satellite galaxies following like loyal attendants, the small fuzzy ellipses of M32 and M110. They orbit quietly, their stars ancient and red, stripped of gas long ago. Beyond them lie other members of the local group, the Triangulum Galaxy, a smaller but stunning spiral, and dozens of dim dwarf galaxies invisible without magnification. Together they form a modest galactic family, bound by gravity, moving collectively through space like a flotilla of lanterns on a black ocean. But the ocean stretches farther, much farther. You can see the next great congregation of light ahead, the Virgo Cluster, a sprawling metropolis of over 1,000 galaxies. They float together in an invisible web of gravity, their collective glow forming a faint haze. The Milky Way and Andromeda, along with the rest of the local group, are slowly falling toward Virgo, drawn by its immense mass. You can almost feel that pull, gentle but inexorable. The cluster sits roughly 55 million light-years away, but on cosmic scales, that's practically the next town over. You take in the diversity of galaxies as you move. Spirals, ellipticals, irregulars. Some are tidy like well-kept gardens, others are chaotic, torn by collisions or warped by unseen dark matter. One galaxy blazes with an active nucleus, powered by a black hole millions of times the mass of our Sun, devouring gas and spewing jets of radiation thousands of light-years long. It's a violent, radiant spectacle, a reminder that beauty in the universe often comes hand in hand with destruction. You imagine civilizations perhaps orbiting far from that core, their skies forever lit by the ghostly glow of their galaxy's heart. From this height, you begin to perceive the large-scale structure of the cosmos, the filaments and voids that make up the cosmic web. The galaxies aren't scattered randomly, they cluster along threads of gravity, forming massive chains that span hundreds of millions of light-years. Between them lie enormous voids, regions almost entirely empty, where galaxies are scarce and darkness reigns unbroken. You realize the universe has texture, not smooth, not uniform, but patterned, like the neurons of a sleeping brain. The Milky Way, once so vast, is now just one glowing node in that unimaginable network. Historians still argue whether the universe's structure resembles a living system, or if our brains are simply wired to see familiar patterns where none exist. You smile at the thought, maybe it doesn't matter. Whether by coincidence or cosmic intention, existence seems to echo itself on every scale. Atoms orbiting like planets, galaxies clustering like synapses, each level a reflection of another. Perhaps that's not illusion but symmetry, the universe's quiet way of saying everything is connected. You glide farther into intergalactic night, and the distances begin to break your sense of time. Light that began its journey billions of years ago now brushes past you, the final message of galaxies that may already be gone. Some of them are so distant that their light has been stretched by cosmic expansion into long, lazy waves of red. Galactic ghosts fading into infrared size. You think of astronomers staring at that redshift, calculating the age of the cosmos, realizing that everything is moving away from everything else. It's an elegant heartbreak. The further we look, the more we see what's already left us. Yet even in that vastness, the universe refuses to feel empty. The faint background radiation, the afterglow of the Big Bang, bathes everything in a whisper of warmth. It's the universe's baby picture, a fossil of light left from when everything was a glowing plasma soup. The Milky Way, Andromeda, Virgo, all of it grew from tiny fluctuations in that ancient glow. You can almost hear it, a static hum that once filled radio telescopes with confusion until we realized we were listening to the echo of creation itself. You pause for a long moment, hovering amid the infinite. From here, the galaxies form constellations of their own, each one a self-contained cosmos. Each one with its own potential for stars, planets, and maybe even stories. It's dizzying but not alienating. If anything, you feel more connected than ever, because this web of galaxies isn't something separate from you. You're built from it. An arrangement of atoms forged in one corner of one galaxy, now thinking about them all. The Milky Way may be small compared to the cosmos, but it's the smallness that gives it intimacy. It's home because it's finite, knowable, reachable. As you turn back, the Milky Way gleams faintly behind you. one swirl among billions, a single note in the universal symphony. You understand now that scale doesn't diminish meaning, it deepens it. The farther you travel, the more precious home becomes. The galaxy may be tiny against the cosmic backdrop, but it's where wonder learned to speak. You hover in the vast dark between galaxies, your mind stretching to contain the scales you've just crossed, and it suddenly strikes you how absurdly disproportionate everything is. The numbers stop behaving like numbers. They start to feel like poetry or maybe satire. The universe loves exaggeration. You think about where this all began, with one small planet circling an average star in an unremarkable spiral arm, and then about where you are now, floating among billions of galaxies. The contrast is dizzying. The Milky Way, that sprawling system of hundreds of billions of suns, has become nothing more than a fleck of dust in an ocean too large to imagine. You can't help but laugh softly. It's the only sensible response to this level of insignificance. Perspective is tricky like that. On Earth, a mountain feels enormous. From orbit, it's a wrinkle. The sun dominates the sky. From Andromeda, it's invisible. You start stacking scales in your head just to see how far down you can go. Earth's diameter, about 12,742 kilometers. The Sun's 1.4 million. The Milky Way's span, about 100,000 light years. That's 950 quadrillion kilometers, give or take a few astronomical units. Then you zoom out to the local group, a cluster spanning 10 million light years, and beyond that to the Virgo supercluster, then to the Laniakea supercluster, which stretches 500 million light years across. Historians still argue whether Laniakea counts as a single coherent structure or simply a poetic gesture of naming. The word itself means immeasurable heaven. The universe, it seems, agrees with the name. The mainstream fact: the observable universe extends roughly 93 billion light years from edge to edge. The quirky tidbit: because space itself expands faster than light beyond a certain distance, most of those galaxies you can see are already unreachable forever. Their light can reach you, but you can never reach them. It's like receiving postcards from a train that's been accelerating away since before you were born. The cosmic horizon, scientists call it. The limit of what the universe allows you to witness. You think about that for a moment and realize that the word observable might be the most humbling adjective ever invented. Still, your imagination refuses to stop scaling. You zoom inward again, collapsing reality until you find yourself back on Earth, standing somewhere familiar, maybe a quiet hill, maybe a city balcony at night. The galaxy arches above you, that milky stripe now comfortably reinterpreted as home. The strange thing about perspective is that it's reversible. No matter how vast the cosmos grows, the view from a single human set of eyes always feels central. The brain doesn't compute relative size, it computes meaning, and meaning is stubbornly local. You tilt your head up, thinking about how photons from distant stars have been travelling for thousands of years just to collide with your retinas. Each one left its source long before the first civilizations rose, long before history even began. The light arriving now from Deneb in Cygnus started its journey around the time humans invented agriculture. The Milky Way's edge glows faintly, a bridge between the infinite and the immediate. You realize that every starlit night is an act of time travel. You're bathing in ancient history disguised as gentle light. The numbers keep pressing in though, impossible to ignore. Our sun, enormous to us, would be dwarfed by Betelgeuse, which itself would be a mere speck next to Vulcae Canis Majoris, a supergiant so vast that if it replaced the sun, its surface would stretch beyond Jupiter's orbit. Meanwhile, each of those stars is an atom compared to the galaxy. You start stacking again. Planet, star, solar system, galaxy, cluster, supercluster, universe. The ratios are obscene. The Milky Way is to the universe what a single raindrop is to Earth's oceans, and Earth itself is barely a mist on the surface of that drop. Historians still argue whether our species' obsession with scale began as humility or ego. The ancients thought the heavens revolved around them. Modern humans discovered they revolve around nothing, and immediately started building telescopes the size of office buildings to prove it. You smile at that contradiction. Maybe it's not arrogance, maybe it's defiance. Knowing how small we are, we keep insisting on understanding everything anyway. There's something wonderfully irrational about that. You turn your imaginary gaze outward again. watching galaxies drift apart as space expands. The further they are, the faster they move, a cosmic illusion caused by the stretching of space-time itself. One day, most of these galaxies will slip beyond our cosmic horizon, their light forever unreachable. The universe will appear emptier, colder, quieter. Someday far in the future, astronomers, if any still exist, might look up and see only the fading glow of the Milky Way's descendants, unaware that countless other galaxies ever existed. Perspective isn't fixed, it changes with time too. The cosmic view we have now is temporary, a privilege of being alive in this particular epoch. And yet, even knowing all this, you can't feel insignificant for long. The absurd scale doesn't make life meaningless, it makes it precious. You start thinking about probabilities, the odds of the sun forming, the odds of Earth orbiting within the narrow habitable zone, the odds of life emerging, of evolving consciousness capable of staring back at the stars, numbers so vanishingly small that they border on impossible. And yet, here you are, you, a momentary pattern of atoms, aware enough to grasp the size of everything else. You are the galaxy noticing itself. You let that realization settle like a stone dropping into deep water. Maybe that's what meaning really is, not being large or important, but being aware of smallness and loving it anyway. The galaxy doesn't need to know your name, it already knows your chemistry. The iron in your blood, the calcium in your bones, they all come from its ancient furnaces. You are a measurement of its memory, a temporary expression of its ongoing experiment with existence. You look once more toward the Milky Way, that glowing spiral that now feels like both cradle and metaphor. Against the infinite darkness, it's just a whisper of light, but somehow that whisper has produced languages, cities, laughter, and the curiosity that built telescopes to see this far. The universe may be incomprehensibly large, but the part that can wonder about it, that tiny flicker of consciousness, is the rarest structure of all. So you smile into the dark, letting the numbers collapse back into awe. You no longer need to decide whether the galaxy makes you feel big or small, it just makes you feel real. You turn slowly, letting the universe settle around you like a deep breath and drift back toward that delicate swirl of stars where everything you know began. The Milky Way glows faintly beneath you, a spiral of memory turning in the dark. After so much distance, so much scale, returning to it feels intimate, like coming home after years away and realizing the house has been quietly spinning the whole time. You can see the soft curve of its arms again, the faint shimmer of gas clouds, the pulsing rhythm of stars being born and dying. For all the noise of cosmic immensity, this galaxy feels almost quiet now, a kind of serene heartbeat at the center of your awareness. From up here, the meaning of small has changed. It isn't an insult or a reminder of fragility, it's a measurement of precision. The Milky Way contains perhaps 400 billion stars, and yet it somehow produced one planet where matter learned to notice itself. The mainstream fact: our entire species, every person who has ever lived, fits into one infinitesimal fragment of a spiral arm called the Orion Spur, the quirky tidbit. If the Milky Way was scaled down to the size of Earth, the whole solar system would be so smaller than a virus, an invisible speck inside an invisible speck. Historians still argue whether knowing that should make us humble or euphoric. You decide it's both. You hover for a long while, watching the Milky Way rotate. It's easy to imagine it as a living thing, a vast organism made of light and time. Its arms aren't rigid but flowing, curling and uncurling with every revolution. Stars flicker on and off like neurons firing in slow motion. In that sense, the galaxy is thinking. Though not with words, thinking in fusion and gravity, in the quiet arithmetic of existence. Every orbit, every spark, every death of a star is another thought passing through its body. You realize then that maybe consciousness isn't confined to small things like brains. Maybe galaxies are aware too, just on scales too grand for us to perceive. Down in one of those curling arms lies a single yellow star, so ordinary that a passing observer might miss it entirely. Around it circles a tiny world covered in blue oceans and restless weather. On its surface, creatures who can barely survive the vacuum of space spend their nights trying to understand the galaxy they live inside. They build telescopes, send signals, argue over meaning, fall in love under skies filled with light that left its source before their species existed. It's a beautiful kind of madness. You can't help but smile at the thought. If the Milky Way could speak, perhaps it would say that all this wondering, the questions, the art, the awe, is its own way of seeing itself. We are not separate from it, we're its consciousness made local. The atoms that form our eyes were born in ancient supernovae, scattered throughout these very arms. When you gaze at the Milky Way, the galaxy is literally looking back at itself. Recognizing its own reflection in your pupils, that's not metaphor, it's physics disguised as poetry. Historians still argue whether meaning can survive in a universe so indifferent, but maybe indifference is the wrong word. The cosmos doesn't ignore us, it includes us. Meaning isn't given, it's discovered, built atom by atom in the minds of small creatures who dare to ask. The universe may be cold, but life is its warmth, and every question we ask is a spark that keeps the fire burning. Perhaps that's the point of scale, to remind us that the smallest lights matter most when everything else is dark. You drift closer now, crossing back into the spiral arms. The stars grow denser, their light reflecting softly on the invisible dust. Each one you pass hums in its own key, a different note in the galaxy's endless chord. Somewhere below, the sun shines faintly, its warmth washing across a cluster of planets, one of which hums with cities, forests, oceans, and late-night listeners trying to fall asleep under a distant ceiling of stars. You imagine all of them, every person, glancing upward, seeing the same shimmer, unaware that the light they're admiring has just brushed past you on its journey through eternity. You think about how fragile it all is. A single gamma ray burst from a nearby system could sterilize entire regions of space. A black hole could tug apart the orbits of stars like loose threads. And yet, somehow for billions of years, this small arm of the galaxy has remained stable enough to harbour life. The odds are outrageous, the coincidence is absurd, and still here you are, conscious in a moment so specific that it will never exist again. Maybe that's what makes existence precious, not its permanence, but its impermanence. You pause at the edge of the solar system, looking back one last time at the galaxy that raised you. The spiral glows faintly against the darkness, its arms fading into the void like breath on glass. You realize the Milky Way doesn't need to make you feel small or large. It only needs to remind you that you are. Against all probability, you exist, and the galaxy will keep spinning long after your heartbeat ends. But for now, your heart and its rotation are in sync, two rhythms echoing across unimaginable distance. You whisper to yourself, softly, reverently, that being small isn't the opposite of significance. It's the condition that makes significance possible. The galaxy may never know your name, but you are made of its atoms, and that's a kind of immortality no myth could improve upon. You let go, letting the image of the Milky Way fade into the dark, and as it does, you feel not smaller but vast. The stars begin to dim now, their edges softening until the sky becomes a single sheet of deep velvet. You let the image of the Milky Way settle somewhere behind your eyes, where thoughts turn into dreams. The spiral keeps spinning slow and steady as if it's breathing for you. You think about everything you've seen, births of stars, deaths of giants, collisions of galaxies, and realize that none of it felt alien. The universe, for all its magnitude, has always felt familiar, like a memory of something you've always known. You imagine drifting backward through the arms, past clouds of gas glowing like candle smoke, past quiet planets turning endlessly in the dark. Every bit of it hums the same song, the one that begins with hydrogen and ends, for now, with you. There's comfort in that continuity. The galaxy doesn't hurry, and neither should you. Your body feels lighter. The spaces between your thoughts widen, like the spaces between the stars. The noise of daily life fades, replaced by the slow rhythm of the Milky Way's rotation, once every 200 million years, and somehow perfectly on time. You smile because you understand now. Stillness is just movement at peace. As your eyes close, the spiral remains, faint but steady. The dust, the stars, the planets. They blur into a soft glow that could just as easily be the warmth behind your eyelids. You're part of it still, whether awake or dreaming, orbiting through time at the gentle speed of light. Good night, traveller of galaxies. May your thoughts drift easy, your heart stay small and bright, and your dreams spiral quietly on.